Okay, let's get started. So it's 8:10. We're still missing, I think, 10 people. So hopefully they will join later. And welcome. My name is Chusen Wu. I'm from the University of Tennessee. And
I'm Justin Broughton. I'm with Google, Earth Engine team.
Hi everyone, I'm Samurai. I'm with Maxar, but here I'm representing the Google Earth Engine Community Catalog.
Welcome everyone. And so this workshop, we're going to go through how to access Google sensing data in the cloud and how to visualize, how to do some analysis just using the browser with one line of code. And so as long as you know how to click the buttons, you will get through this. Okay, so you don't need to have programming skills. If you have this path, but don't worry, we will make sure that everyone can follow through, and then you can make changes. You can do whatever you want, and you won't break things. So everything will be reproducible here. And so the QR code, you can scan the QR code or type the URL. We're going to go through that shortly. And also for this workshop, first we're going to give you a brief introduction into Google Sensing. So before it gets started, how many of you have used Google Sensing before? Maybe, okay, more than half. How many of you are the first time that you have never used it? Yeah, so roughly half. How many of you have used the Python API before? Only three. So for those of you who used Google Sensing before, mostly JavaScript API, right? Okay, cool. So hopefully after today, you'll be convinced to use Python. That's how it goes. But I mean, in reality, you can use both, but it'd be great to know like when it's better to use JavaScript, when it's better to use Python. And hopefully when we go over some of those hands-on exercise, and you will realize how easy it is to use Python rather than writing 100 lines of code using JavaScript. Python mostly using Geemap and the API, you can just 1 or 2 lines, you can do a lot of complicated stuff without having to write many lines of code. And so this workshop has 3 components. The first one is intro to Google Sensing. Will be taught by Justin. And then Sam will be cover the Earth Engine community data catalog. Earth Engine has a public data catalog officially maintained by Google Sensing team, but there's also a large community data catalog. So for those of you who would like to share data or you want to use some data that not available through the official data catalog, and that will also be a huge asset. And then after that, we go through the workshop notebook, show you step by step how to use Google Sensing Python API and also Geemap to do spatial analysis in the cloud. So it's going to be 3 hours and 30 minutes. So everything will be available through the notebook. And I also talked this before, so there are recordings on YouTube if you want to watch it. I actually taught this one in October, 2 months ago at the Google Geo for Good Summit. Everything is recorded. So, and we also have exercise here and also the local installation. So for those of you who are new to Python, you don't have to worry about this. This is only for users that already know how to install packages locally. But what we're going to do here in this workshop, everything can be accessed through Google Colab. So I'll just click the link and then open it up. Then you should be able to follow through. And here is our information here. And for those of you who are joining online, you can also check out the Zoom link here. Yeah, that's pretty much what we have here in this document. So next, I'm going to hand over to Justin to give you a brief introduction to Google Sensing, especially for those of you who are new to Google Sensing. And you might be wondering, like, why do we use cloud computing? Like, why cannot we just use traditional desktop computing? And I've only started using Google Sensing, I think, 6 or 7 years, since 2018. And since then, I've been using daily in my workflow, and it makes life so much easier. So the take-home message for those of you who are new to Google Sensing is to imagine that you are watching TV, watching movies. So nowadays, how do you watch movie? Online, right? YouTube or Netflix, Amazon Prime, whatever. Do you still buy DVD? from the store and then go watch at home? Of course you can, but I think maybe 1%, 5% people are still doing that. So the same here. We are in the transition from desktop computing to the cloud. And once you get into the cloud, you don't really want to go back to watch movies using a DVD-ROM, or even if you have that. So there's kind of these things that you need to keep in mind. And hopefully after today, kind of the goal is that to teach you how to watch movies online, but it's how to stream geospatial data from the cloud using a browser without having to download anything. So you can have access to petabyte data, just a couple lines of code, as long as you know how to do it. So it's kind of like the free, the entire movie database produced by human, like the unit is free for everyone. It's kind of like the entire geospatial database is available for you to use if you know how to use it. So that's kind of the goal of this workshop. Next, I'm going to hand over to Justin to introduce the basics. So for those of you who already know, just maybe use that as an opportunity to review some of the concepts of Google Engine. And yeah, so Justin.
Thanks, Qisheng. I think that's a really nice way to describe Earth Engine in terms of like video streaming. Yeah, so what is Earth Engine? And it sounds like a lot of you are using it. So hopefully you'll learn something through a different lens if you're already familiar with it. And for those that aren't, I hope this is helpful for you. Right, so Earth Engine is Google's cloud-based platform for geospatial analysis and visualization. And so it's made up of three components. There's the data catalog, which at this point has over 1,000 data sets, and I think it's like between 80 and 90 petabytes. So they've collected and gathered up data from most government agencies that are, providing imagery and other data sets, and we make a copy of it, store it on Google's servers, and it's co-located with Google's, sort of massive compute power. So getting data from off the disk and into compute nodes is very quick. And then you access this data and this compute power through an API. And just a real quick demo for those of you who haven't used Earth Engine, what this sort of means. So right now we're in Colab in a Python notebook, and I've written a small chunk of code here that will grab grab Landsat imagery, mask out clouds, and then just create a mosaic of cloud-free pixels and then display it. And so if I just run this, what's happening right now is we've sent a request to Earth Engine servers to do this kind of work and send back little image tiles to be displayed in this map. And so this has all happened in real time. No raw data was transferred to the computer, just these visualization chips in the map. And it happens really quickly. So right now we're looking at San Francisco Bay, and I can zoom out and new data will be grabbed. A request has been made. It knows that we've zoomed out and it needs to generate new image tiles. And so it's doing this on the fly in real time, creating composites. And so it's hugely powerful for being able to do global scale analyses, very quick visualizations in sort of real time, but then also the ability to create really long running complex analyses that could take multiple days, that can just run in the background and produce data that would be impossible to produce on a local computer. Oh yeah, I should put this in, in slideshow. So the data catalog and the servers, you don't have to know anything about that. That just exists on the background. What you interact with in Earth Engine is our client API. And the API is a way for you to express some instructions for Earth Engine, what you want it to do. You import some data, you do some manipulations on it, you request a visualization or an export of some summary statistic, for instance. And so what's happening is you write these expressions with our API. Those expressions get packaged up into an expression model that the Earth Engine servers understand. We call that the REST API. So when you click the run or zoom out, a new request is made through this REST API, which goes to Earth Engine servers. They get to work on this request, and often it splits up your request into many small pieces to send out to lots of computer nodes, and then puts them all back together and sends them back to you through this REST API. And then you get the result as some bit of text or image tiles, or maybe a file in Google Drive. And you can express Earth Engine language either in JavaScript or in Python. And I think often people get really nervous about choosing one or the other. And it shouldn't be the case, because 95% of what you write in Earth Engine is this Earth Engine language, which is the same essentially between Python and API. So Earth Engine, the API, it's an object-oriented model for programming. And so we have these classes, these things or nouns like images or features, these data models. And then you do things with them, these methods like clipping them or filtering them. And so the objects and the methods, the way that you express operations in Earth Engine, this is the same between Python and JavaScript. The only differences are maybe how you define a variable, for instance. So here we have JavaScript and Python, the same bit of code. And the only difference here really is that in JavaScript, we have this var indicator to say that we're going to be defining a variable. And in Python, you don't have to do that. And then we're defining a function. And in JavaScript, you would have to call a function on it. In Python, you would call def for definition. But the rest of that is all the same between these two languages. So if you just sort of focus on learning the Earth Engine language, you can be working in JavaScript or Python and go back and forth however you please, for whatever suits your purpose at the time. And Earth Engine, when I'm working with it, I often think about it in terms of like building something, like building a house or a crafting project. But in this case, we're sort of building data. And what I mean by this is that we have these materials, we have these data objects, which is maybe analogous to a bunch of wood. And then we also have tools, things that we can do to these materials. And those are these methods that we just talked about a second ago. And so you've got these data models, these tools to manipulate it, and then you work with those two things to start building an end result, like a house. And I think a lot of people want to start at this like doing phase. And I think that is the wrong way to approach it. I think with LLMs now, this is maybe becoming more easy. You can just tell an LLM, I want to do this thing, and you describe to it what you want to do, and it will give you code. Earth Engine isn't quite there yet in the LLMs. I don't think they've been trained on enough data. And also, there's so many different data sets and specific things about data sets that it's hard for Earth Engine, the LLMs, to get it right in a general form. Oh, sorry.
A large language model. ChatGPT.
Yeah. So ChatGPT or
Yeah.
Bard. Thank you. And so I think it's really important to like step back if you're going to use Earth Engine and you envision yourself using it a lot and want to do something big with it, is to not think about doing right away, but learn about the materials, the methods, and then what you actually want in the end. And then, do the doing after you've learned about it. And so I want to focus here on the materials and the tools of the Earth Engine trade. So the two big materials that we have to work with are raster and vector data. And this is sort of ubiquitous data if you're working in the geospatial field. And the way that we have raster data described in Earth Engine is as an image object, and that is a grid of pixels. Each pixel describes some observation, and they might have bands, they have metadata that describe the information, and then we can take a series of images that represent a time series for a specific scene or location, or we can have a series of images spatially, a large mosaic across the landscape. And when we aggregate these images together, we call it an image collection. So our raster data, the object types are image and image collection. And then we have vector data, and this is like lines, shapes, polygons, points. So we have three types of vector data. There's the geometry, which is the most basic type of data we have, and that just describes vertices, and lines may be connected between these vertices that describe regions. And then we have features, which have a geometry underlying it, but then also an attribute table attached to it. So in a shapefile, for instance, you'd have an attribute table. So and each row in a shapefile would be a feature, essentially. And then so if we have a series of features, like in a shapefile, we would call it in Earth Engine a feature collection. And there's also another question. If I understand, I think it's the same thing. Yeah, so if you imagined, like what kind of data do you work with in imagery? Yeah, like Landsat or?
Yeah, it's still the same under the hood, but it's optimized. It's stored in the Google Cloud, but it's optimized for cloud computing. Kind of like you're watching a movie, like Netflix. You're still watching a movie, but you're not accessing directly the original MKV file or OV file, but it's still on the server, but it's just optimized for cloud computing.
Yeah, so all the metadata would be exactly the same. If you were to download a given image from USGS, you could also query Earth Engine to give you that specific image by the ID, and all the metadata would be exactly the same. But as Qisheng said, we do some things to optimize it, and I'll get into that a little bit later too. Yeah. Right. So we just covered the geospatial data types that we have in Earth Engine, but there's a whole bunch of others that are common among programming languages, ways to express other data types like an array or a list, dictionaries, numbers, all of these really common data sets. We have an equivalent in Earth Engine, and they're optimized for Earth Engine's servers. We call them server-side objects, not to be confused with client-side, which is often a tricky thing for new people to understand. Maybe we'll get into that a bit.
Yeah, we will talk about that when we go through the hands-on exercise.
Okay. Yeah, so the point here is that we just, we're considering the data types that we have to work with, the objects that we can do things with in Earth Engine. And if you're curious and want to learn about these, one place to do it is to go to the Earth Engine reference docs. Up on the tab here, we've got reference selected. And if you click down to the client libraries, this first layer of drop-downs, these are all of the Earth Engine objects. I don't know how many. And so, just to dig a little bit deeper on what an image is, we have this grid of pixels, and the image has metadata. So we can know the time that it was of the observation, for instance, maybe how much cloud cover there was, the quality of the image, any other kind of attributes you might want to include with image data are attached to the image object. And then an image collection, you can think of it just as a table of images that are all related to each other. So here we now have, for instance, we could think of this as a column of images, and each row in this table is a specific image. It has its own grid of data, its own metadata. And then with the geometries, we have different subtypes of geometries, all of them listed here. These are specified from the GeoJSON specs. And so a feature, of course, has a geometry, and then it also has information metadata attached to it. For instance, maybe an ID or a descriptor about some zone, the name of the rectangle, for instance. And then if we have a collection of features, you can think of it as a table. So we have this series of rows. Each one of them in this table is a specific feature with its own metadata. And so for each of these objects that we've just described, they have a series of methods, things that you can do with them, the tools that you have to work with them and manipulate them. And so similarly, if you're curious about what you could do with an Earth Engine object, you have a feature that you've imported into Earth Engine, and you're wondering, what can I do with this? A place to start is to look in the reference docs and drop down the feature object, and then you'll see the list of things that you can do with it. You could get the area of it. You could make a new feature that is the bounds of it. If it was a triangle, for instance, you could call bounds on it, and then you'd get a rectangle back. You could get the centroid of your triangle, for instance. So spend some time getting familiar with what you can do with objects. And then some considerations, some different things about Earth Engine that might not be what you would expect if you're working with ArcGIS or QGIS, for instance. So some of the big things are scale. So I'm going to talk about how Earth Engine deals with scale. So if you're working with ArcGIS and QGIS on local files that you've downloaded, those pixels have a set scale. So if it's Landsat, it's maybe 30 meters. Each pixel is 30 by 30 meters. So when you do an analysis in QGIS, maybe you subtract one image from another to get the difference over time. Just inherently, that process is happening at 30 meters. But in Earth Engine, when we ingest the data, we create these pyramids. So if we ingest a Landsat image, its native resolution is 30 meters. So we have the raw original data, but then to make things really quick to visualize and process later, we also create additional layers, these pyramid layers at different scales, at larger scales. So there might be a scale at 90, 150, and so on. And so there's all these scales available to you, and you have to specify the scale you want an analysis to be in. So the output is sort of determining what the scale will be during all of the analysis, which is sort of funny to think about. You think about the endpoint first. What scale do I want the result to be in? And you're given opportunities in all these functions to specify what the scale should be. Question?
Yeah, so actually this is one of the things that I've run against Google versus or something, is that on one of those platforms, I know exactly what I'm doing, whereas to some extent, some of the processes of Google Earth Engine appear like a black box. So, for example, if I'm downloading Sentinel imagery, doing a bunch of analysis on it, and asking for an output of 10 by 10 meters, I'm not really sure, did it fan sharpen the image? Did it, like, what happened under the hood to give me the result at the resolution that I asked for? And where do I go to actually get that level of information that helps me put things down in my publication that I put, like for me to know exactly what it did?
Yeah. I mean, if you wanted to get really specific about it, there is a computation graph, but it's really hard to interpret. So if you did need like absolute repeatability and like evidence and proof, there's a record. But the easier way to do it, well, easy isn't the right word, but we have doc pages that describe what happens in scale and projection. And you should be able to intuit from those what has happened in your process. And I'll talk about them here too. And we could talk again later if you need something more specific. But if you go to the reference docs, there's a page on projection and scale that describe how it's doing it.
Yeah, there's no native pan sharpening, but if you have scales, for example, sentinel bands, if you take a 20-meter band and a 10-meter band, and if you're doing, for example, a reducer on that, yeah, you will want to know like whether the reducer is returning the 20-meter or the 10-meter pixels. I can see use cases like that. But there are examples to show how you can deterministically say like, hey, for this band, apply this resolution for the reducer versus something else. But Earth Engine by itself does not apply a native pan sharpening in any way.
Yeah, so I can also add a comment. So basically, it's very important to understand the differences between like desktop and also the cloud, because the reason why Google is so fast because it's not compute at the native resolution. Unless you really request, if you export the data, you're doing some statistics, but most of the time you can forget about the resolution. Just like when you're looking at Google Earth, zoom in and zoom out. So when you zoom in, the resolution becomes higher, but the area becomes smaller. When you zoom out, you see the global, but it doesn't need, you don't need the kilometer, the meter resolution. It's doing the computation at the reduced resolution. And so it's doing parallel computing, it subdivides the images into small pieces. Yeah. And it send one piece to one server, another piece to one server, and then get the result back really fast. And if you noticed earlier when Justin showed you the Google Color example, when you zoom up, you see like it's image popping up like by square. So those are basically the tile. And for most users, forget about the resolution. You can just get all the images at the global scale. You can do a computation. Then you can quickly zoom in and zoom out to see the results. And later, if you need to do, for example, do some statistics, for example, you want to calculate the lane cover area, other stuff, there's always a parameter that you can specify the scale. And this is where it really matters. But you don't want to run the native computation at the very beginning because otherwise not computation efficient. You're not going to do like global scale studies like in seconds but you can do a reduced resolution in seconds. And so some of the example exercise we're going to go through later, we show you the power of like when do you need to specify the scale, when you can just forget about it, or most of the time you can forget about the scale and the projection. I think, but those two components are very important when you're doing desktop computing. For cloud, you don't want to mess up those things. Otherwise, your script going to run into memory issues. Yeah. You will get more examples later. For now, it's more like very abstract. But then when we have example, you will see how quickly you can utilize those to do larger scale computing. Only deal with the scale and projection when you export the result or when you do some statistics. That's really you need to, otherwise the result you might be, oh, I'm using desktop computing ArcGIS. You give me this number. Why Google says you give me the other number? Because it's not using the same scale doing the computation. And there's also like base efforts, like the resources is limited. And I want to do global scale, but it might not allow you to do that. But Google says it might figure out the base resolution within the memory limit to get you the result. So that's why sometimes you will see the result are not exactly the same because of some of the scale and also projection issues.
And you have something similar locally too. Like if you look at Envy or Esri's ArcGIS or something like that, you have, it'll ask you, do you want to calculate or generate pyramids? And what the pyramid is doing is generating these RRD files, right? And those RRD files are massive. And think of this as us generating, like us or Earth Engine basically converting this into a cloud optimized geotip. And each of those geotips have basically these native browse resolutions at which you're browsing. When you're actually doing the computation, and when you're extracting the data out, whether you're exporting it out, there are a list of functions in the Earth Engine's catalog of functions that will allow you to specify projection as well as scale. And those are the two ways in which you'll be able to specify pixel size as well as what native resolutions. Let's say you want to reproject it to UTM rather than using EPSG 3857, you can do that.
So that is true.
Yeah.
You can specify the scale and the projection. Where it gets dicey is like, when I am doing something in Envy and I post in the resolution, I can tell it, do a pixel aggregator, do a nearest name.
You can do that here too.
Exactly the algorithm it is using. That is where I feel that Google Earth Engine feels a a little more, I wonder what it did.
Well, you can do that. So they have a reduced resolution function, and you can select how it aggregates the pixels by mean, median, max, min.
Yeah.
And also you can choose what resampling method is used. So by default, it uses nearest neighbor, but you could tell it to use bicubic or bilinear. Yeah. But right, so the scale is determined by map zoom level, or as Sam said, many of the functions will have a scale or CRS parameter. And so it's important to set these whenever you're given the opportunity to be sure about what you're getting. And if you want to avoid resampling, just ensure that it's the native resolution. And you can find that from the image metadata. You can call, like if you have an image object, you can call .projection.scale to know what the native resolution is. And so it won't then resample. And so this is a similar story with the projection. It's determined by the output. So you have to specify what projection you want it to be in, the results, what the analysis should be done in, what projection, as opposed to maybe a local desktop software where it just uses whatever the native projection was. Yeah, so what I'm showing here is just a couple examples. This is taking a MODIS image, and we apply a function to it, unit scale. So we're just, it's an arbitrary example here, but making it 0 to 1, the values, that doesn't really matter. But then in the end, we are displaying it to our map. So the end result is map tiles, and map tiles need to be in this Web Mercator projection. So, MODIS starts out in some specific sinusoidal projection, but in the end, it needs to be in Web Mercator. And so it has to do a reproject. And it knows that in the end, we want map tiles. It has to be in this projection. So the first thing that it does before it does anything else is it does a reproject to whatever it needs to be in the end, and then processes your data. So this is sort of this black box kind of thing. But these diagrams will tell you when it will actually do the reprojection. And this is a more complicated example where we have specified a reprojection right here. So we've got our MODIS image. It's in this sinusoidal projection. We apply a function to it. And we wanted that function to work on some really specific projection, that was not the original projection. So we called reproject, and it actually does it then before it does the function. But in the end, we're displaying these map tiles, and those map tiles need to be in Web Mercator. So it does another reprojection to get them into, and at each of these points, it could have been resampled. But the important point here is that if you call reprojection on somewhere in your process, it'll first reproject the input images, but then it may do another reprojection at the end to display them. And again, projection is determined by, map functions, zooming in and zooming out. You can reproject, or anytime you're given a CRS parameter, you can specify projections. And if you don't specify projections, it just uses the default projection, which if it's a single image, it will use whatever projection that image was in generally. But if you're working with a composite of images, a mosaic, so for instance, if you have Sentinel or Landsat and they span a really large region so that you have multiple UTM zones, you've got multiple projections that you're trying to run this analysis, this compositing mosaic on, for instance, it doesn't know which of those UTM zones it should do the analysis in and what the results should be in. And so the engineers have set a default projection, which is WGS 84, just lat long, and the pixel size will be 1 degree. And so this is a case where it's really important to be setting your projection. If you're working with a lot of images in a collection, generally you're going to have to set a specific projection. Don't just accept the default. And so one way that you can do that is with the set default projection function. And also when you're doing export, you could set the projection at that point too. I'm realizing now this is like the most boring part.
No,
And we've started out with the most boring part, but just up front, you know, we can maybe just establish some disclaimers about Earth Engine.
Can I just hammer down one more point on this is, so another key difference is when you're doing this in your local system, when you mosaic two images, right? Your system is aware what the output is going to be, right? It knows it's a geotiff, or for example, if you're mosaicing two geotiffs, it knows the output is going to be a geotiff, or you can, you know, create something else, some other format. It'll ask you the resolution while you're going to do the mosaic. It'll ask you like, what scale do you want as the output, right? Mosaic operations in Earth Engine don't. Most operations in Earth Engine will create something known as an Earth Engine compute object. Earth Engine compute object have no memory, which means it doesn't know which images it used to get to that mosaic. That's the reason it does not save any of the resolution information or metadata information or any of those things. So this method, the set default projection, is a way for you to attach that information back to that computed object. That's one of those key differences is you will often see this. I mean, if you're actually running a call that every time you do, whether it's a mosaic or whether it's a median mosaic or whatever else you do, most of the time, if it's a computed object, that information from the base imagery is not passed on to the computed object. And hence there's also ways in which you can pass other properties. It'll also not copy, for example, if you had a time series that started in 1980s and went on to 2022, the computed object will not have those date information, but you can then force it to actually attach that information back if you want it to. So those kind of things are like common in Earth Engine. I just wanted to mention that.
Yeah.
Yeah, another point I want to make is also for new users, it's important to know that like why Google Sensing is so fast. So Google Sensing doesn't really compute until you get the result, until you try to export the data or you try to run some statistics. Compared to desktop computing, when you're doing a mosaicing, because you need to specify where you're going to save the output or something like that. Google Sensing, everything is in the cloud. It doesn't actually save the data. So you can write a very long script doing all the computation, but if you don't ask to see the map, see the data, it's actually not computation. It's just everything. Just you can think about just all the graph, the step, and it's sent to the server. But you don't ask for return. It's not going to do anything. So there's something that you might need to pay attention. And when it's doing the computation, sometimes it's really fast, sometimes it's really slow. So it depends on how complicated is your script, and also whether you specify the projection, the scale or not. For new users, I usually recommend that forget about that. Don't mess up until you're really advanced. You know what you are doing, because if you set the scale at the very beginning, 1 meter, 10 meter, you're not going to be able to do like large scale because the memory is limited. So we will have some example to show you later how to get hands-on on those examples. Okay, so next we're going to
Just want to mention one other thing, important thing about Earth Engine that's different from like desktop computing is there's two processing environments with Earth Engine. We call one of them the interactive environment, and that is where you are getting requests back within 5 minutes very quickly. So like when we'll do the demo later, that'll be using the interactive environment. But then we also have this batch environment, which allows you to do these really long running large requests that might take days, where you export to like Google Drive or cloud storage.
BigQuery.
Or BigQuery. And when you're working in the interactive environment, you're limited to 5 minutes. And so I think people often are sort of expecting the world, they want to do this really complicated analysis and be able to view it at the same time within 5 minutes. And if you're zoomed way out, maybe that's possible because we're working with, low resolution pixels. But the interactive environment is really meant for, kind of quick prototyping, exploration, verifying that, the results are what you would expect. And then once you're happy with sort of a sample of what you're doing, then you would export the full running task with the batch environment. So that's that. Just to summarize, learn the Earth Engine objects and their methods. Be considerate and be thinking about scale and projection, and be aware that there's these two processing environments, and use the Earth Engine guide pages to, help learn about these things some more.
I feel like we should do another presentation transitioning your local workflows to Earth Engine. Because then we can talk about all of the differences between local and not so local. So, hi everyone. I'm going to talk a little bit about Earth Engine data. And for this, I might actually go to Earth Engine. So I'm going to give you your first look at Earth Engine code editor. You're not going to use the code editor because this is JavaScript, and we'll be talking about Python today in this class. But I'm going to show you the code editor just because code editor is the simplest way for accessing Earth Engine. And the reason I'm saying it's the simplest way is because in terms of what needs to be installed or what needs to be packaged into, this is the most native way of thinking as batteries included, right? Like everything is already present here. All of the functions have already been predefined by the Earth Engine team. Whenever we are talking about one thing we want to get out of the way is like whenever we're talking about the Python API and the JavaScript API, they are the same API. We have to stop calling them different APIs. They're not different APIs. They're different SDKs. They're different software development toolkits or interfaces through which you can access the same API. The API is exactly the same. JavaScript is actually calling the same exact thing, and Python is calling the same exact thing. They're just wrapped in different programming languages. So let's get that out of the way. There's only one Earth Engine API. There isn't two different APIs. I just want to make that very, very clear. The other thing I wanted to talk about is we talked about Earth Engine having 80 to 90 petabytes of data. So where exactly is that data set, right? If you go into the code editor, right, which is like the most native way in which you can access Earth Engine directly in browser. By the way, most of the example today is also in browser, but this is like Earth Engine's own hosted web page and things like that. So you can actually look for things like Landsat. And what it'll do is it'll show you all the rasters and then tables that are derived or has the tag Landsat associated with it. What that really means is that within its collection, you can actually go in and you can read about the description. You can talk about the bands, image properties, terms of use, and so on. All of this is being done by people in the Earth Engine team. Simon and others have been at it for like years now at this point, who are doing a lot of these things. And you can also find, if you just go to developers, you can actually go to data catalog. And in the data catalog, you can click on view all data sets and do the same exact search. So if you look at Landsat, for example, it'll show you all of those data sets that either are direct Landsat or have the tag Landsat in it. Now the tag could be also because it's a Landsat derivative, right? Like someone created some like product on top of Landsat, and that's why you're able to access that. The last I checked, which was like a few minutes ago, I think there's 1,076 total data sets. At totaling about 90 petabytes plus data. And that's a large amount of data, right? So Earth Engine is continuously ingesting a lot of these data sets as they're getting updated. But then there are also data sets that are created one-off, ones that are generated, but they're not necessarily updated every day, or ones that are like derivatives and they'll be updated like once every 5 years. For example, NLCD classes are updated once every 5 years, I believe, right? 5 years? 3 years. Okay, 3 years. So those kind of things are also in Earth Engine as well. So if you wanted to use something like that, or NAPE, for example, which is updated once every year. So updation timeline for Earth Engine datasets vary quite a bit. So if you're looking into any Earth Engine dataset, and for example, if I wanted to use the global surface water mapping layer, I click on the catalog page and I'm taken to the same information, the description, the band information. So it'll tell me what band it is and things like that. Terms of use, and then citation, which I think is important because all of you are producing scientific grade data. Citation is important for you to then, like if someone else is using your data, you want to make sure that they cite your work, right? One of the coolest thing about this is the fact that you can now click on open in code editor. And what this will do is it'll preload the script for you, some basic script. I'm not saying like this is all that this data set can do. But this is like a precursor of like, hey, what is the bare minimum if I wanted to just look at the data? Can you give me a script? And that's exactly what this is going to do.
And as I'm zooming out, as we were talking about pyramiding, scaling, there's lesser and lesser amount of tiles that are being loaded. The more I zoom in, the more the number of tiles. Hence, the more zoomed in you are, the more heavier the work is for you to load that detailed information. It's the same as like, hey, I want to zoom in and look at a heavy resolution data. The higher the resolution of the data, the more time it's going to take for it to load, right? Okay, so that's the easiest way for you to interact with Earth Engine in terms of like getting to the data. And one of the things that is important for you to notice is that in the code editor window, you actually have a section on called examples. And in the example section, you have a lot of these things. So for example, you have a folder called datasets. And in the datasets folder, if you know who the provider is, and this is one of those tricky things, right? If you know who the provider is, you can go and expand on that, and you can then get to that data set specifically. So for example, I know that JRC is the producer of this one. So you will notice that if I click on the JRC folder, I have all of these from the Joint Research Commission Europe have produced all of these data sets. Dataset, and then we have these dataset examples that I can click on. So I can click on the monthly history example or a global surface water example, and the code will change accordingly. Okay. Most of these codes look pretty similar, but the code does change. So I wanted to show you this. So this is the easiest way when I'm talking about, I'm actually not 100% sure what we're loading here, but.
Point samples.
Oh, point sampling, okay.
Field.
Perfect. So the way in which you can think of these catalogs are that they're stored in Google servers and they're made available to you. You don't have to worry about bringing this data set in. You don't have to put this on your hard drive, and you don't have to roam around with 90 petabyte storage. You don't have to log in a special methodology or things like that. So apart from this data set, you might want to load your own data, right? One of the most important things that you probably want to do is like, hey, did some field sampling. I want to load that data into Earth Engine because I want the analysis in Earth Engine to be the same as what I'm doing in the field as well. I want to like basically plot those points in Earth Engine and do a bunch of things, right? Earth Engine is going to give you natively a methodology for you to attach these things called cloud projects. And these cloud projects comes with a coda. And if I click on it, it'll show you. Right now, for example, it says maximum coda is 250 gigabytes, total file size. You have not uploaded anything, so it's 0% usage. But you get 250 gigabytes per cloud project, and you get about 50,000 objects per cloud project as well. That being said, there is a form if you're a researcher and you need that coda to be uplifted, and because 250 gigabytes, it might have been great 10 years ago, but now with drone imagery, 250 gigabytes is like, it'll go with just one drone survey. You might want to fill out that form and actually talk to me. I'll show you where the form is, and you can fill out that form for additional storage if you need additional storage. The count is not that relevant. Count is think like this as an index, right? If we're using the Netflix example, this is how Netflix knows whether you ran movie number 1 or movie number 2021. Because Netflix is not reading full names, it's just reading index. And index is the quicker way of actually looking at the table, okay? The way in which you're uploading data, and I'm just gonna show, I'm not actually gonna upload any data, but I'm gonna show you is like the GUI way, and then I'm gonna talk a little bit about how you can do this programmatically, because you wanna do this in bulk. You wanna do this in batch, right? So if I click on the new button right here, and click on, you'll get some options. You'll get image upload, you'll get table upload, where you have the all famous or infamous shape files. You have CSV files that you can upload. Now, CSV files do need a geometry column for it to be recognized as, hey, this is a valid geometry. And the geometry column, the geometry has to be configured in a WKT, well-known text format geometry. Only then it'll recognize that CSV as a valid CSV that you can upload. You can upload a CSV with no geometries and still use it for some other application, by the way. I've done that. It totally works. But you can also upload that as well. You can't actually upload an image collection per se. You can create an image collection, and you can create a folder. Image collections are these collections of images, right? So if you have 10 drone flybys of your same site, then you can put all of those 10 images into an image collection and say, site one, drone one, something. Like, I'm terrible at naming, but you get the point. You can name it whatever you want, but that's an image collection. A folder can have multiple image collections. It can have feature collections. A folder is a space where you arrange all your data. So if you're working on, let's say, you're working on like the drought in certain areas, and you need these 20 different data sets, they're from different sources, and you want to bring all of those data sets together, you can create a folder that can then house an image collection, a feature collection, a feature table, all of those things. Another interesting thing, if you upload a CSV or if you upload a shapefile into Earth Engine, it doesn't matter if it's a single feature or if it's hundreds and thousands of features, Earth Engine will always ingest it as a feature collection, or it'll call it as table. So whenever you hear that word table or feature collection, that is what it is doing. So I want, like, these are like some really small nitty-gritty facts, but do not be surprised. You're like, wait, I only had one feature, this one point. Why is it called a feature collection? It doesn't matter. It's just the way in which ingest works in Earth Engine. But it'll show up as a feature collection, but you will still have that single one feature in it. Okay. Okay, but feature collections will obviously have their own features, right? And you can actually pull this. So for example, if I actually pull in census block, for example, this is a good example. So you'll notice here, first of all, it'll automatically name this as table, right? So that might create some confusion. If you hear the word table as the same, but if you expand on this a little bit, it'll tell you that this is a ee.feature collection, right? And if I print this, I'm not going to print the whole thing. There's more than 5,000 features. Earth Engine code editor does not like when you try to print more than 5,000. So what I'm going to do is I'm going to print just the first feature, okay? And it has its own arbitrary way of naming that feature, but it will retain the properties. So this is what we were talking about. So the same as your attribute table in your shapefiles, this is the same. So all of those properties are actually retained in the feature collection as well. Here's another fun fact. If you're doing this, if you want to include date information, Earth Engine will allow you to actually filter by date in a feature collection as well. If you actually create a column that has the date information and specify it by using something called system:time.start. All of this that I'm saying are hidden gems somewhere in the Earth Engine documentation. You just need to dig through or meet me later and we'll talk about your specific data needs, okay? So I just wanted to show you where to find all of this information. There's a whole section in the developers.google.com/Earth Engine. There's a section on asset management. And asset management will give you a walkthrough, basically a much more slowed down version of how I'm presenting right now on things you should or should not do with your image. It'll give you some recommendations. For example, if you are uploading a thematic classified imagery that has 5 classes versus a continuous data collection, what kind of sampling should you use? Should you use mean or should you use a mode, for example? Those are recommendations that are actually included here. And you also have sections on like importing raster data. And you also have things that they will tell you like, hey, if you specify system:time.start with a date, it'll remember that date and it'll associate it with your information, like with your data that you have uploaded, right? So that's important. If I'm going too fast, ask me questions, I'll slow down. That'll give me a chance to slow down as well. Go ahead. Yeah. Not really, because
Can you repeat the question? Because you...
Oh, yeah. So you're asking that, so the question is that so whenever you're importing anything in Earth Engine, whether it's a single feature or a feature collection, it imports it as a feature collection. The question is whether there'll be a problem if it's a single feature that should have been imported as a feature, but is now a feature collection. So in terms of analysis, you can just call that single feature inside a feature collection if you wanted to. You can also filter by attributes and do a bunch of those things as well. So as far as I am concerned, I don't see anything major. Do either of you see anything?
So basically, you can think about feature collection is just like a shapefile that you deal with like locally. So you can have a shape file with just one point, one line. It still is a shape file. So it's being treated when you're uploading, it's uploading as a feature collection. But you can have access to the specific role, specific attribute, specific feature. So basically, geometry is just the shape. The feature is the shape with the attribute, like columns. And then the feature collection is a bunch of those. So think about feature collection is like a shapefile, GeoJSON, something like that. And you can always do filtering, select by attribute, or you can also select by location to get the specific features that you want.
Yeah, and you'll get all of them. So for example, this one, right? The same example for the census blocks, right? You can run a dot size and you'll get like this count, and this will be like probably like thousands of, because it's counting basically the census blocks right now. You can select, like Sheng was saying, like we can actually select a specific feature inside a feature collection. That shouldn't be very hard at all. And even if you're running with just a feature collection that has a single feature, dot first will convert it into a feature, or you can just cast it as e.feature, and you can say, hey, I want you to treat this as a feature, not a feature collection. So you can explicitly cast something as a feature as well, if you wanted to. Yes, go ahead. Do you have any import tutorial?
Let's see. I will show you later how to get access to that. We have a lot of example on the Geemap website. Can show you how to convert, for example, CSV from local computer to a feature collection or a shapefile or GeoJSON locally. You can do that easily, just one line code.
Yeah, and I can like later if you have specific shapefiles or CSVs in mind, if you wanna like have a discussion, we can also discuss during the breaks. Like because with CSVs there is some nuanced like there's some interesting nuance to like the dates that you want to put in, right? For example, Earth Engine uses or used to use something known as epoch time. It still does. It's the time from 1970. It's starting like 1 second. So everything in time is counted in milliseconds from that time, which means that if you give a CSV the time as epoch time, you can then parse it by that time. But if you give it as actual dates, for some reason, you cannot specify that as like, hey, read it as this date format, because Earth Engine doesn't know how to parse that. So it won't actually allow you to filter by date. And I have some examples that I can show you on that piece as well. But anyways, so yeah, go to the section on asset management. There's a lot of ways in which you can upload data. You also have the Earth Engine command line tool. I'm not going to talk about this piece because I believe that there's examples already on how to go to the, and how to upload data. The last piece I want to talk about is, as a researcher, a lot of you might be producing some amazing data sets that are not part of the main Earth Engine catalog, right? But you still want to share it with the rest of the world. So 3 years ago, I started a project called the Earth Engine Community Catalog. And the Earth Engine Community Catalog is basically a collection of me trying to go out there and collecting all of these researchers' data that people have produced and shared under an open license. So I recommend that you share it under an open license, if possible. And then I'm basically going in and collecting these requests from users and bringing these data sets into Google Earth Engine. So this data set, by the way, this catalog, by the way, is not part of Google Earth Engine, but it's something that I created and maintain. There's a GitHub repository in the backend. And if you go to the GitHub repository, this is the way in which people submit data right now. It's saying like, hey, I'll give you an example. Someone submitted this Africa tree cover map, right? A few days ago, 4 days ago, this request came in. They said, we would love for this data set to be included. They shared the link of where this data set is kept. So it's a Zenodo link right here, right? It's a zip file or a TIFF file or something else. They shared the license terms with me and they said, can you make sure that this is available in the community catalog? I didn't find, for example, the original paper. So I reached back to the author. They shared the original paper with me. Then the next step that happens is I will go and download the data, process it, make it Earth Engine ready, and then ingest it back into Google Earth Engine. And this is what the community catalog is actually about, is apart from the main catalog that has about 1,000 something data sets, the community catalog has about 1,608 additional data sets. That's about 300 plus terabytes of additional data. That's not there in the main catalog. So for example, if you wanted to look at building data sets, right? I just recently uploaded this data set, which is the combined building data set from Google and Microsoft produced by Vita. I ingested all of them into Google Earth Engine, and this is now available. And in the same way in which you have example links in the main catalog, you can actually click on this, and hopefully this will load the example script. I'm also going to show you the app in the meantime. I also built this app. This is an easy way for you to explore. Sometimes I will take the time, if I have extra time, to build some apps. So this one, for example, I can go into, let's go to Belize. And what this will do is it will load the building footprint data set. That's a combined building footprint data set from Microsoft and Google for a specific location. Sorry, yeah, going down to the buildings, like it takes a while. And you will notice here that, yeah, this was one example where I was like, okay, also a simple example where I can just load the building footprints. And there's some sample code for you to test and experiment with this as well. So the community catalog also has an examples folder. And if you go to that main page, there's a section that says getting started. And getting started will walk you through the steps of like, how do you get access to it? It's open access, by the way. You don't have to request anything special. It's openly available to everybody. You can then also shows you how to submit your bring your own data. So it walks you through the steps of like, hey, my lab produced this amazing data set. I really think it'll be useful for other people to use it. You can then use this template to actually submit the data set request. And then the last but not the least, there's the link to the example folder. And this example repo will then load on your Earth Engine code editor where you'll be able to see all of those examples as well. You can also search. So for example, if I wanted to look at hydrology data set, this will show me all of those tags that links to hydrology. So for example, water quality data set, tile drain croplands, hydrologic curve numbers, and those kind of things. I can look at land cover. Let me show you also like the DEM. So land cover will show you like all of these data sets that are available under land cover. And if I go into, for example, world settlement footprint, right? This is now officially available in Earth Engine catalog as well, but let me show you something different, like Landscan. Landscan is produced by the Oak Ridge National Lab. It's a global population data set. I go in and you'll notice here that all of these data sets will have citation information. So whoever actually produced this data, I make sure that there is citation information available so that other people, when they use your data set, can cite your data set, because the idea is to connect the two pieces. I don't want to claim that I created this data set, right? And that way I don't get the emails about like, something is wrong here with this data set. I was like, okay, write to the author, please. But you also have the sample code, and the same way in which, the same way in which you had sample code for the first data set, you'll notice that you can then write additional codes that will do things like this. And I can get Landscan, day, night, Landscan USA day, these kind of things. But more importantly, yeah, you will notice here that there's license information and change log information. So every time I go and change a data set, I will also update that information out there for people to use. So you can browse, and there's like everything from population to hydrology, ocean, shorelines, analysis ready data. There's like terabytes of data here that are not part of the Earth Engine main catalog. Go ahead, you have a question. Yes. Mm-hmm. It's in Earth Engine servers, but I have Can you repeat the question? Oh, I'm so sorry. The question is, where is this data set living for the community catalog? So most of the Earth Engine community catalog data right now, I have a large data grant, which is like the same way in which you had the 250 gigabytes quota. My quota is very large. It's a few terabytes. And I am basically ingesting them into the Earth Engine servers right now. I also have copies of most of these data sets available, and so that they're kept locally, but that's one of those additional projects that I wanted to explore at some point in time, where we also want to make it available so that people don't have to go natively through Earth Engine, but they can use other plugins to access the data, similar to how data is kept in like Amazon Data Registry or Google's Data Registry and things like that. Yeah.
A lot of these data repositories
Yeah.
Online that review or DOI.
Yeah.
Publish the data sets there.
Mhm.
They have a DOI inside.
Yeah.
So when you ingest a data set that already is posted on an open data repository.
Yeah.
DOI, then you just.
I just link the Zenodo repository and I copy the same DOI over. Yeah. The difference here is that for you to then take that Zenodo data, you have to pre-process the data. You have to download it. If there is hundreds and thousands of these files, you have to figure out a way to upload this into Earth Engine. You have to name them, make sure the metadata is correct and all of those things. So you don't have to do any of those pieces. That's where I come in and I'm doing that for you. But you maintain your original DOI, you maintain your original data quality, your citation, all of those pieces are there. I'm not modifying the data. And if I am, I'm speaking to the data providers first, where the level of modifications that I'll do is like, maybe the naming convention has a dot or a period. Earth Engine naming convention cannot accept a period. And you have like 5 periods in the name. I was like, okay, I'm going to change your name. And I will write that as like pre-processing steps in the data because I had to change that. But the DOI is maintained. This is basically an easy way to take terabytes of these data sets that are in Zenodo, in Dryad, in Figshare, but are very messy or kept in ways that are not easily accessible, and bring it so that you can just use code and you don't have to worry about the data part of it. Yeah.
There must be some criteria you must follow. Like, for example, I have a data set that's local to California.
Yeah.
But how do you put your, like, how do you decide?
I have data sets the size of a city. I don't, usually I do not like go with like, hey, only global data sets are welcome, local data sets are not welcome. That is not my criteria. I'm not here to like, hey, this is a better data set, or this is a bad data set or something. If it's something doable in the sense that if a data set request is less than a specific size, then I will do it. But sometimes there are data sets that are more suited or better suited in the Earth Engine main catalog because how big they are. There's a request for an Aster data set right now, the total size for which is about 130 plus terabytes of data. I am not going to be able to ingest it. It's just me. There's no team behind me. I'm the only one who's maintaining this. So I will usually ask the requester, I'll say like, can you please post this as a request to the main catalog page, right? So that's my only criteria is I check for license, whether or not something is under an open license, right? There was a request for GADM, the boundaries, right? The global administrative demarcation boundaries or something. It turns out the GADM boundaries, the license is non-permissive. It says you cannot redistribute this data, which means that I, as an individual, do not have the right to redistribute this data. Even though it's useful for thousands of people, it's unfortunate because a lot of these data sets in the world do come with some restrictions. So that is the reason that all of these pages have license information, because I also want to make sure that people don't think of this way of like, hey, I want a hacky way of getting to a data that's not, that's not easily distributed, but I want someone else to access it and make it available. So
Yeah,
I have to respect the license.
The bottom line is that at least the awesome community catalog is much easier to get your data published compared to the public data catalog. You need to submit a request, and then you need to have many upvotes.
Yeah.
Basically, some property data set that the community really like it.
Yeah.
It makes you the OSNG data catalog. The OSNG team might take over, but
yeah,
sometimes it might take years. Yeah, because there are local data that people want to be in the public data catalog, but
yeah,
they can only accept a limited amount of data set. So if it's not feasible, then I mean,
yeah, and I'll let the users know if it's not feasible. I'll tell them here's an alternative, right? Like, for example, I did a USGS historical topo maps, and I did 100,000 topo maps from the last, I don't know, from the last 100 and something plus years, all the way from like 1900s. And you can get this in Earth Engine using the community catalog. You can actually look at like topo maps, and I think, yeah, there you go. USGS historical topo maps. These are great. These are things you can't explore in Earth Engine otherwise, but you can explore it because this was done in Earth Engine. And the process is extremely complicated because you have to go to the USGS website, negotiate a token, and you have to get each of these geotiffs. Then you have to make sure that there's metadata attached to it. Naming convention is weird. So the way in which this project is done is that it's community supported in the sense that a community tells me which data set is important to them, right? And I'll take the time to basically evaluate it, ask questions. If there is some issues, I'll return back to them, and then we will submit it more. This is also open for volunteering, by the way. So if people do want to volunteer and say, hey, I want to be a maintainer and I want to help maintain or like spend some hours for you to curate, feel free to talk to me after this. But yeah, so this is it. And one last thing I'm going to show is there's a change log where you can also see like the latest. So every week or every 2 weeks or 3 weeks, as I upload the data sets, you will notice that there's like this huge array of change log that tells you where these data sets are. And I'll also post it on LinkedIn or other places as needed. So with that, I'm going to hand it back so you can do your hands on. Thank you so much.
Okay, thank you, Justin and Sam, for the great introduction. So the take-home message is that, okay, it's out there. There's a tons of geospatial data. It's free, accessible. And next, I'm going to show you actually how to actually do that. So essentially, the entire movie data set is free for everyone. Now, you want to watch a movie, you want to do some analysis, how to actually get started. And we're a little bit behind the schedule, but it's fine. We are very flexible. So all the notebook is available online. You can try it out later. So the most important thing is to make sure that your account is ready to use the Google Earth Engine Python API. So you all have a Google Earth Engine account, right? Anyone without an account? If not, you need to sign up. Otherwise, you cannot do anything. You can just watch. So for the notebook, you can click the link here, and then it should take you to the Geemap website. So basically, Google Earth Engine provide the JavaScript API and also the Python API. So Sam and Justin already show you how to use the Earth Engine JavaScript code editor. But we're going to use the Python API. But under the hood, they're the same. So Python API, JavaScript API, under the hood is being converted to is the REST API or something else, whatever, and then to the server. So they are pretty much similar. If you already know JavaScript, Python is pretty much the same. The only difference is that the Python JavaScript API has the code editor, has the map, the interface, and then everything for you to interact. The Python API is just the computation. So you can think about Google Engine has two components, major component. The API has computation and also the visualization. So the JavaScript has both. The Python pretty much has computation. There's not really much visualization capability. So Geemap is created to fill the gaps. I started this one, I think, 3 or 4 years ago, right after the pandemic, teaching students how to use Python API, but it was not easy at the time. So I spent some time trying to like make the connection and use open source packages to do that. And so the Geemap has been officially adopted on the by the Earth Engine team. So if you go to, let me quickly show you. If you go to the Earth Engine documentation, for example, here, get started. And now you can go to the documentation. You can look at any examples. So most of I recommend if you're new, try to go through documentation. You don't have to run everything, but at least get an idea about what kind of things you can do and also some of the concepts. For this workshop, we are going to get into some essential stuff, but it's probably only cover 1 to 5% of what Google Engine can do. There are a lot more things you can do. But if you can open any examples, so for example, go through here, usually you will provide the JavaScript and also the Python. You will see they're pretty much similar. And if you click the Python setup, you see now you use Geemap. So Geemap has Geemap.core and also the extra. But for user, you can just import Geemap. Well, we go through the examples later, but I'm just showing you that now Geemap is adopted here. So all the example they're gonna go through, you just use Geemap. So if you want to use the Python API, Geemap can help you so much easier to visualize the data and also the computation result. Okay, so once you're here, what you can do is just open in Google Colab, right click. And so this is where it looks like. For those of you who are new to Google Colab, so you can think about it's just a cloud computing environment that allows you to write Python code. Similar to Google Docs, right? I imagine all of you have used Google Docs or Microsoft Office online. It's the same thing for writing text, but this is like for writing code. And then you can execute, you can see the result. On the left side here, upper left corner, there's a button, table content. So this is a very long document. You can go through if you want to. Yes? So if under the Google Docs here, right? And then there's a workshop notebook. If you click that, it should take you to this website. And then there's at the top, there's a page. You can right click, open in collab. And then it should open this one here. And so you can, upper left corner here, there's a table content. You can take it, you can hide it if you want to. So this is, like I said, it's a long document. So you can just click, navigate through if you want to. And the first step I would recommend is to change from the dark mode to light mode, because some of the widget right now doesn't fully support the dark mode yet. So you might see it like weird. The contrast is not very good. So I usually recommend for now, you can go to the upper right corner here. There's a settings button. And then when it opens up, on the left side, it should open like side. And then from here, I recommend that you change to light for now. If you're really into the dark mode, fine. But you're just going to see the interface might look a little bit different because Geemap built on top of iPad widget and some other open source packages. Not all of them are fully support the dark mode yet. So change to light mode, and then you should be ready to go. So Geemap has already been pre-installed in Google Colab. So you don't have to install it. But because this notebook use some additional packages not pre-installed yet, so I would recommend you just come here, and then on your keyboard, press Control/. If you're using Mac, it's Command/. So you see here, or you can just manually remove the hashtag at the beginning. Just backspace, remove it, highlighted it, and then we're going to install the packages. Okay, so click the buttons on the left side and just run the cell, or you can Control Enter on your keyboard. It should work the same way, and then it's going to pop up, ask you to authenticate. So just click Run anyway. Then it should install the packages. Yes, question? So for example, what we're installing in here, Google Colab is a cloud computing environment, but it's temporary. If you close it, everything will be gone. So it's just like think about a virtual computer in the cloud. They allow us to do something, and it's free. And so in that way, you're not installing anything on a computer. You're installing in the cloud, in the temporary server. Once you close it, everything is gone. Yes, yeah. Yeah, it's in Colab. So Colab is like have a base all the packages. Geemap is already there, but we have some additional packages you want to use. So that's why we're installing. And hopefully you will see it successfully install all the packages. And then I would recommend usually if you, for this case here, it works just fine. There's no error messages. But sometimes if you install some packages, it's going to show you like incompatible or something. It's recommended if you go to the runtime, and then you can say restart section. So this is kind of like on Windows computer, install some software, and then do you want to reboot? Usually it's a safe, you can just reboot it. So I'm going to restart the section and then say yes. Okay. And then we are done. So basically now it's rebooted. So here you can also remove this all the logs. So if you have your mouse on the left side here, there's like what's this like icon here. It used to be like plus icon, but now you need to actually move outside, move it from the left to the right, and then you show the cross to create it. If we move from inside, it's, I don't know, this is the kind of recent changes. It used to be, you can see right away, but again, move from the left to the right, and then there's a cross icon. You can just click on it. It will remove like the long logs of the script. And that's pretty much it. We have installed the packages. Now the next step is just to run it. So for all of you, we can just use the run cell, or like I said, Control/, or Shift, or Control Enter, or Shift Enter. Control Enter is going to run and then you stay there. Shift Enter is going to move your cursor to the next block. Okay. So you can, for example, I can just Shift Enter. And on the left side shows you 1 second. That means less than 1 second. It was executed. And the next one here, this one is the where user might have issues because your account might not be ready. So you can click this one, geemap.e initialize. And it's going to probably, oh, for me, you see, it's just like, it doesn't ask me to authenticate. So let me actually, let Let me turn this one off just to show you the step. Because I have already added this token on this collab, so it's already automatic authenticate. This is a new feature for new users. Just forget about it. I don't want to make it complicated. So let me. Okay, so for this one, it's I can quickly show you. So basically, it's going to create Earth Engine token, EARTH engine, and then underscore token, TOKEN. And this one here, the token, I can show you. It doesn't show you all the stuff, but basically this one comes from your local computer. You need to have already used it. And the file path, don't worry, for new users, forget about it. I'll just quickly show you where does it come from. It's coming from your local computer that if you already authenticate. So if you go to, for example, your users directory, and then you need to show the hidden directory in here, and then it's under .config, and then Earth Engine. You need to open the file. I'm not going to open it because those are token that you can get access to my account. So if you double click the file, open it, and then copy all the content, the entire content. And then if you come back to here, just paste it, you will be able to, and then enable notebook access. So in the future, if I use Google Engine, you don't need to click the button to authenticate every time. Anyway, so yes. Yes, you can run it in the cloud. You can also run it locally. So you can just download the notebook. If you want to run it locally, you can here come back to this website, and then there's a button here to download the notebook. Actually, later I will actually run it on my local computer. But Google Colab is for new users that don't want to install things. Then you can just use the Google Colab. But the first step is I want to make sure that you can authenticate properly. Then you can use it. Otherwise, you cannot really do anything. So let me restart my runtime just to make sure that I show you how to authenticate. Okay. So I'm going to run this one again. And then now, because I disable the token, now if I run it, it asks me to, oh, it's not asking me. Because I have notebook access. So let me turn this one off. And let me restart my runtime. I just want to show you the step-by-step how you get authenticated. Yeah. So let me show you the other way. I will just type EE to authenticate. You don't need to type this. If you just run that one, if you have not authenticate, it should pop up. EAUTSE. So if you run that whole block, it should show you something like this. Okay. And so what we need to do is just click the link. And then it's pop up, ask you to log into your Google Engine account. So all you need to do, I think one thing you need to pay attention to here, you need to choose a cloud project. So if there's already something there, perfect, you can just continue to the next step. If there's empty, then you need to create a cloud project. So somewhere in here, you can create a cloud project and make sure that you have the admin right to create a cloud project. So that's what I mentioned in the email that I sent previously, that if you're using your university email account, now most universities do not allow you to create a cloud project by yourself. So to create a cloud project to authenticate Google Engine is free, but the cloud project can be using other services. So you might accidentally using other stuff that charge money, the university need to pay. So that's why it's recommended to use your personal account. You need to enter your credit card, but it's free, okay? But don't try to mess around with other services. You might end up with an unexpected bill that you need to pay. But in here, you should be able to create a cloud project. And then once you're done, then you should select this one, right? Then just click the generate token and log into your account and click the allow. So this is where the one-time authorization token. So you're going to click this one, copy, and then come back to the notebook in the input box here, Control V, hit enter. Okay. Yes. Yeah, make sure that you have this one. Otherwise, you cannot do anything afterwards. Okay. So once you authenticate.
Cost.
Mm.
So for non-academic.
Mm. Uh,
We want a project that has
mm. So here, actually, you have the instruction. Let me quickly in here on the notebook actually show you the step by step. If this you're new, you don't have cloud project, you can. Let me open the Earth Engine here. There are two ways you can create a cloud project. You can log into your code editor, and then upper right here, upper right, if you click your icon, your name, you will see like I have one project in here, but you can also like register a new cloud project. If you already have one, perfect. If you don't have one, you can also do it in here. So you will need the cloud project to use the Python API. Otherwise, it's not, you cannot use it. So in here, if you raise the new cloud project, and it's going to ask you, okay, raise the non-commercial or commercial. Then you say, okay, unpaid uses. So this one is for academic use, and then you can say, or academic research, and then click next. And you can say, choose a cloud project to register or existing one. You can just create a new one if you don't have. So here shows you the step-by-step instructions. And once you have this one, authenticate. So what this one is doing is authenticate and generate a temporary token onto this temporary server. Once it's closed, it's gone. And that's why I usually recommend, if you are familiar with Python, you want to install things locally, authenticate locally so that you don't have to go through the same steps every time. And the alternative is to get the Earth Engine token here and set the token so that you don't need to authenticate every time. But now, for new users, I don't want to make things too complicated. Just authenticate this one, and then you are good to go. So run this next two code blocks. Okay, map equal to Geemap.map, and then map. If you can see the map, you're ready. If you cannot see the map, then we have to resolve the issue. Otherwise, you cannot do anything. Can you see the map? How many of you can see the map? Who cannot see the map? So raise your hand if you cannot see the map. We need to fix this before we move to the next step. Yeah, for the online, it says that Google has not verified the ad. Yeah, just grant access. Sometimes it depends on the account. So just allow, just whatever pop up, allow, and then you should be able to do that. Another question? Sam? If you cannot see the map, raise your hand. So once the map is created, you can explore here. And then, for example, you can click the button. You can see some of those interface. We cover those later. But at least for now, you can, for example, click the button in the upper right corner. And so those are basically what Geemap is about, is having those interactive widgets or tools that allows you to interact with the map, okay? And then you can display the data. We can do some computation. We can select something. But right now, it's pretty simple. It's just like similar to the Earth Engine, something like this. So what we're trying to do is to have some similar experiences that you can do using the JavaScript, but right now we're doing that in Python. So it's the same idea, but this is not officially supported, native support by the Earth Engine Python API. It doesn't have this. So this is what Geemap is about, built on top of those mapping libraries that allows you to visualize the data in the cloud. Okay, and so this is what you can do in the Google Colab. You can continue to follow through. So next, I'm going to actually run that on my local computer. So for those of you who are familiar with Python, you want to do that on a local computer, you can follow the step to do that. We don't have time, so I'm just going to directly open Jupyter Lab on my local computer. So what I'm doing here is I go to this one, and then you can just download this one to your laptop or your computer, and then I'm going to my downloads directory. Let me remove some of these files. Okay, so I can just open my terminal. Again, unless you know what you're doing, don't follow this step. You just continue to use Google Colab. I'm just going to contact activate GE. Oops. Yes. The local means you don't have to authenticate every time. And then you can also directly access the file on your local computer. So if you have some data you want to convert from, for example, set file to Google Ascending, you can run it locally. And the other thing, you can also use whatever IDE that you want to use. You can use Visual Studio Code, you can use Python. There are a lot more things you can choose from. Basically, if you're using Google Colab, you can run the computation, you can save the result, it's saved to that temporary. If you close, everything is gone. But if I'm running locally, everything, if I save the result, is on my local computer. You can also basically more communication with the cloud. You can send data to the cloud. You can get data from the cloud. You can save things, and also it's one time only. You don't have to authenticate every time. And you can also use the IDE. You can use Visual Studio, Python, whatever that you want to use. You can also integrate with desktop.js. I can actually use Geemap with QGIS or ArcGIS if you want to. But the Google Colab is just a light environment that allows you to install all kinds of things. Locally, you can install additional packages that you might not be able to install on Google Colab. So it's like more flexible. Yeah. So here I'm just going to open this one on my local computer. It looks pretty much the same, except that it's a lot more smooth. And some of the functionality might not work on Google Colab. I will let you know. Then something breaks on Google Colab, but it works fine locally. Okay. So here, this is what it looks like on my local computer. And you see, I also have the table content. It's the same thing. Again, don't worry too much. It should be the same experiences. I'm going to zoom in a little bit so we can see a little bit better. All right, so this is what it looks like on my Jupyter Lab. So I can just come here, do the same thing. I can just import it and initialize. So what this is doing, initialize means you are initialize a connection to the Google Engine server, okay? You can also authenticate, basically you have a credential. Once you authenticate, Google knows it's coming from you. It's not unauthorized access. Initialization means you are initialize connection to Google Engine server. And I think there's only 5 concurrent connections you can have because it's a free resource. You don't want to abuse them. You don't want to like have 100 computer and then sending all the requests all at once from you. It should be a shared resource that being utilized by everyone. So, and once you initialize, then we can create a map. So I'm going to show you here, right? It should be pretty much the same. The difference here, let me uncheck this one, is that locally, if I hover my mouse, you see it's actually showing up automatically. I don't have to click it, but something doesn't work on Google Colab. So you see the interface looks, the icon, the style looks a little bit different. It doesn't matter. The functionality should be the same. So I start from now, I'm going to use the log from my computer here. Okay, so this is the map. By default, it's using the OpenStreetMap, and compared to the JavaScript code editor, is actually using the Google-based map. So we don't have the authorization to use the Google-based map because you need to use the API. So we just change it to the OpenStreetMap, but you can use other alternative if you want to. So this is what you need to continue, okay? Anybody having issue seeing the map? No, you use the Colab. You just continue to run this one. I'm just saying I prefer using this locally because it's much more smooth, okay? Yes? I can show you how to do it later, but if you really want, like I showing here, okay, that's fine. I can quickly show you, right? This is basically the command line, but you need to use a Conda. Do you have Conda installed on your computer? Okay, so I can quickly show you, okay. Open your terminal, okay? And then you can just copy the command line, for example, from here. I can use a Control C. You can do it line by line. Anyway, For those users that are using Google Colab, fine, don't worry. I'm going to spend just a minute or two just showing you if you want to set it up on a local computer. So here, you should already have Conda installed and Conda or mini Conda on computer. So if you type the Conda command, you see it's showing up in here. And what I'm going to do here is just to create a new Conda environment. I can say Conda create dash n is the name of the environment. And then you can use, for example, GE or whatever name you like. I'm just maybe GE, for example. I already have the GE, so I cannot use it again. And then you can specify the Python version 3.11 or 3.10, 3.9, whatever you like. Hit enter. Again, forget about, if you don't know about Python, you can skip this one. Okay, and it's gonna ask you to install. You say just hit enter, yes. Then you should create the Conda environment. Okay, once it's created, so Conda basically the package allow you to create virtual environment. So you can think about here, in this building, right? All the rooms are used for different purposes. So basically you're just creating a virtual room, and inside there you can do whatever you want. You can install the packages. Once you're done, you can remove it, you can clean up, you will return back to the environment. So next, Conda activate. E or G, whatever, activate a new environment. Now on the left side, you should see like parentheses. E means they were getting into this environment. And then the next step is to install Mamba. So Mamba is a package manager, is a called drop-in replacement of Conda because it's so much faster. So it's recommended if you're installing packages that are quite complicated, sometimes it takes a while to resolve the dependency. So you're trying to basically have everyone in the same room, but some of people don't like each other. Then you need to figure out a way how to make it compatible because the package version is sometimes quite complicated. So you can just Conda install this -c and then Conda first. It's coming from the Conda first channel, and then Mamba, hit enter. So basically we are installing somebody else to get in charge of the room. And then we can ask him to install the packages for us. You see here, it's pretty quick. And once you finish that, so anytime you're using Conda, you can just say Mamba something. So I can just say Mamba install -c Conda first and then Geemap, okay? And the reason that I also install PyGIS is basically we have some optional dependencies that not comes with Geemap. Geemap only the core, but we can install a bunch of other stuff. So just type PyGIS. And then it should take, the first time it might be slow, might be a minute or two, but after that it should be very, very fast. And so what we're doing here is the setting up on your local computer so that you don't need to use Google Colab. And okay, you see here, 51 megabyte. I already have some cache, so it doesn't download all the stuff, but it's essentially installing 386 packages. Although we are only specifying 2 because each package stands on the shoulder of other packages. So this is why it's sometimes you're trying to figure out to have these 386 people work together. They are fighting with each other. So this one makes sure that they are compatible with each other. So once it's done, then you just Jupyter Space Lab, open it up, and then you will be able to use that, okay? If you have questions, you have issue, if you want to set it up later, I can show you when we have the break, okay? We are overdue the break, but I just want to make sure that you can see the map. And then, let me see what time it is. Yeah, then maybe let's take a 12 minutes break, and then I can help you if you have any questions. Then we come back, and then we'll move a little bit faster. Again, don't worry too much about that. As long as you know how to click the button, you can see the result, you can zoom in, you can zoom out, and then you can always digest it later. But we have a lot more content to cover after that. So let's get back at, 10. Yeah. If you're using Google Colab, keep it on, don't close it. Otherwise, you need to restart again, okay? So let's get back at 10 o'clock and then have a break. We also here if you have any questions. Okay. So 10, so we only have 1 hour and a half. But we move faster, a little bit faster later. Yes? Oh, okay. Yeah, for those of you who want to set it up on a local computer, so you need to install, you just type Miniconda to find this one and then install it. So just type Miniconda and then go to the web page. So for here, you can download the package for your operating system and then install it. Once you install it, then repeat the step I showed you earlier, conda install, basically the same, the step in here. Then you can authenticate, you can download the notebook and then you will generate a token on your computer under your user directory, and then you will be able to copy the content and then paste into Google Colab. If a new users, just authenticate every time, and then later on you can set up on a local computer. So here, if you open this one, basically this is the file containing the secret. Open it and then copy and then paste to Google Colab. It will work. Yes. Oh, you mean the font size? Yeah. Sure. Yes. 你是用什么？是哪个方面的？没，这里有个 Intel 这个不行吗？Intel，你有可能，但是这个网，嗯，应该不是以4年other release 吗？不行的话，你就用那个 Anaconda，Anaconda 也可以，可以到了。 Anaconda. Okay. Okay, let's get started. So it looks like some of you are very interested in setting up on your local computer. That's great. So earlier I showed you the step because I already have a Conda installed on my local computer. For those of you who are new to Python, so Miniconda or Anaconda basically is a package management that allows you to create virtual environment. I put the link in the Google Docs in here. If you want, you can click the link and then you can open the website. It should take you to here and you just download the packages that for your operating system. Then just double click, install it. And once you are done, then you can just type conda. So all the commands that I showed you earlier, you should be able to use the same thing. And the reason that you want to install on a local computer because you don't want to authenticate Google Sending every time. You don't want to click so many buttons. And also the data that you export from Google Sending can be saved to your local computer directly. But if you're new to Python, probably it's too much for you right now. Just use Google Colab, you'll be fine. I also have a lot of videos showing how to install it if you want to on my YouTube channel. So to save some time, because we only have 1 hour and 30 minutes, we're supposed to have at least 2.5 hours for the remaining, but we're gonna move a little bit faster. But like I said, you'll be fine. Don't worry too much. So here I start from now. I'm gonna use my Google Colab locally. So earlier, show you this one here, Geemap.map. So basically, this is Python, it's object-oriented language. So what we're doing is trying to create a map. So Geemap is a Python package and it has a lot of functionality. So map is a class. So basically we are creating a map and then assign it to the variable and then we display the variable. And so this map is interactive. You can zoom in, you can zoom out. You can also, if you want, I can click upper right corner here, the icon. And then on the left side, this one called layers, okay? So you can click, you can actually turn the layer on and off if you want to. You can, there's also a slider here if you want to change the slider. So everything is interactive. Every component is just like a widget. You can add widget, you can remove widget. We'll show you more examples later, but right now, this is basically the base map. This one has nothing to do with Google Sending yet. It's just a simple base map. And then we're gonna pull the Google Sending data, we're gonna display that, okay? So by default, you will see the map and also on the left side here, you have some drawing toolbar, zoom in, zoom out, full screen if you want to. Okay, so the full screen only works locally. On Google Colab, you cannot full screen, okay? So if you come back to here, it will not work, okay? But if you really want, you can right click and then you can say view output full screen. You can see the full screen, but it's not native full screen. So here, if you find it too crowded, it's too ugly, you don't like it, you can remove things if you don't want them. So here you can also change the map center. By default, it's a global map, but you can pass in the center equal to, for example, latitude, longitude, the zoom level, and the height. So essentially the map is customizable. So right now you see the map is centered around the US. It's not the global scale. At the zoom level, basically, the larger the zoom number, the more zoom in it is, okay? So you can, for example, I can say zoom level equal to 10. You see it zoom in a little bit more. So zoom level increase like by 1, right? So right now zoom level 10, 9, 8, 7, 6, 5, 4, right? 4, earlier it was 4, right? It looked like this. So you can easily customize the zoom level. You can also customize the control, right? So right now you see here, the data control is the one, the upper left corner here. This one is allows you to search the data. We'll show you examples how to use later. The one on the right is called the toolbar control. And also the drawing tool is called draw control. So you see here, I turn those off. Right now, you only have this by default, the zoom level, the zoom control, and also the full screen. So basically, like I said, everything showing on the map is just like a Lego. You can put things in, you can take things out. It's up to you what you want. So you can always customize the map. Next, let's add some base map. Okay, by default, it's using the OpenStreetMap, but you can use an A3 base map, for example, here. The base map equal to, so when you create a map, you can pass in a parameter go base map, and then, but for new user, you might be wondering, right? Okay, how do you get the name? I don't know the name. It actually on the right here. If you click the upper right corner, and then the second row, fourth column, if you click it, it actually allows you to change the base map. So this is hundreds of base map available. You can choose any base map you like. For example, I want to the Esri topo map, for example. You should be able to switch it. So basically, the name on the drop-down list, if you don't want to click it, you can remember the name and then passing to the call. But it allows you to change things programmatically. So for example, I can use maybe what else? Maybe Esri national map, whatever. Like, so choose any map. Like, this is something you cannot do in the JavaScript core editor. Okay, you only have the Google base map, but this one you have tons of base map. You can, if you already also produce your own base map, you can also put it in if you want to. You just need to use the function to call it. But you can also, after you do this, I can, for example, I already added. So you can say add open topo map, for example, right? You will add it automatically. So again, this is not Google sensing. This is just like simple web mapping, the base map that you can add to the map. And so if you want to see all the name of the base map, you see right now total we have 143 base maps. I can show you the first 10. So basically what you need to do is just grab whatever you like. For example, I want to utilize the NLCD 2021. You can just copy, select, and then I can come back to here, map.add base map, replace it, and then shift enter. Come to here, you see the base map, the NLCD, right? So everything is just a tile layer. Think about this is the tile layer, basically just like Google Map, OpenStreetMap, or whatever base map, they usually have the so-called tile URL that allows you to add to that. And again, this is not Google sensing yet. It's just a simple web URL. And you can zoom in, you will see more details in there. Okay, so that's about some very basic how to create a map, how to customize what it looks, and also how to add some base map. So next, let's get started with Google sensing. Yes. Yes, we have examples later. Okay. Yes. Mm-hmm. Yes. Oh, so in here, for example, I already add a bunch of data layers right in here, right? And if you really want to, you can, let me create a new code block so I can hover my mouse in here and then click the plus icon. So this one shows you, so the layer here, if you click upper right here, it will show you all the data layer in here. So you can turn it off. So this is one way, but you want to remove them. Sometimes it's easy to create a new map and then just don't let it. But if you really want to control it, let me show you how to do that, right? So right now I have 1, 2, 3, 4, 5 data layers. And you can just type m.layers. It will show you all the tile layer. So basically, this map right now is like the Lego, right? These five pieces. If you don't want, even to remove something, you can do that. So I can come here. I can say m.layers equal to m.layers, okay? And then I can say square brackets, colon, -2, for example. So what it's doing here is I only keep the last 2 layers. I remove everything else. So if I run it, you see, now it's gone. And I only have 2 data layers. This is a little bit more advanced. Like if you basically everything is customizable. You can take it, you can add it, you can remove it if you want to. All right, so that's about the simple base map. And next, let's really get into Google sensing. So far we spent too much time on getting the basics and the theory, but now really how do we also movie, right? How do we watch high definition movie without having to download it? Okay, so the first one we're gonna try out here. Justin already covered the basics: image collection, geometry, feature collection. For most of you, I think the most important is the image. A single image. Image collection is a bunch of images. It can belong to the same sensor or something else. Yes. Oh, zoom in a little bit. Okay, is it better? Okay. So here, Google Engine is server-side object, so everything is under e-doc something. Think about this as a black box. And if you want to see it, you need to actually open it. Okay. So in here right now, what we are trying to do here is that I want to use some DM. So this is the unique identifier. Everything in the Google Engine data catalog has a unique ID, kind of like our social security number in the US, whatever identification number. And you assign it to the variable. So that variable become an object, and then you can display object. So if I run this one, you're going to see this here, right? So this is very much similar to you using the JavaScript code editor. You can see the attributes. So this is so-called the metadata, right? If you use a length image, you might want to know when was it acquired, what's the cloud cover, what's the date, what's the sensor attribute, something like that. So this is pretty much the same that you go to the Earth Engine website, you look at the, let me quickly show you here. For example, I go to the, here, data set, right? So I can just simply select this one, and then I can come here, I can paste it. You'll be able to find the data set, for example, opening here. So what we are doing is actually grabbing all the information from the website and then display on the notebook. So in that way, you don't have to moving away from what you're working on, trying to use different browser. Everything can be accessed from here. So next, that's actually how to visualize. Okay, you see, this quickly goes through this code block. All the example I'm going to show you, it pretty much follow the same workflow. You create a map, you add some data, you do some analysis, you add the result, and then display the map. Or you can display the map first, and then you can keep adding layers to your map above. So the map is interactive. You can display in multiple locations. It will be the same map, or you can create a new map if you want to. So here, quickly, I'm showing you, right? I specify a center around a location, latitude, longitude, and then zoom level. And then I'm asking, okay, pointing to this Google as saying DM, and then you need to visualize the data, okay? So Google Engine, the Python API doesn't really have an interface. Unlike desktop GIS like ArcGIS, QGIS, that you can open the image and then you can change the symbology, open attribute. It doesn't have that. Geemap has, I will show you later, but it's very important to understand how to do things programmatically. So here, in terms of visualization, you have the minimum, the maximum, and also the color palette. So allows you to actually specify how you want the image to look. The color palette here, this one is so-called hex color code. It's basically RGB, okay? The first two digits are red, green, and blue, okay? 6 digits. It might be hard to remember, so Geemap makes it so much easier for you to just use any name. And then you can say add layer, m.add layer. So we are pointing to that data set. This is how I want to visualize that. And then just add that data layer to the map and then display it. So you can see essentially what we're doing right now. We are watching a movie, okay? And you're just telling the computer, okay, I want to watch this movie. And I want the RGB, like this is how I want it to look. Like just like changing your monitor, like the brightness, your color channel, whatever, and then display it. So we are not actually downloading any data. So everything in here is actually streaming the data from the Google Engine server to your cloud, to your computer. And for those of you who really want to see what's behind, yeah, I can do the same thing. I can just m.layers and you can run it. So you will see here, this is the URL. This is the one actually where the data coming from. It's through this URL. If I zoom in and zoom out, it's going to request new tiles. And I can also quickly show you here. If I go to my Chrome, and then I go to my tools developer, I can show you under the hood what this one is doing. So under the network, and again, if I zoom in, you zoom out, you see on the right here, right? It's like showing very quickly images, PNG, something. It's actually not downloading the original data. Everything is just like, for example, PNG, you see here, the base map, Earth Engine data is the same idea. So if I'm using Google Chrome, it's under here, it's the 3 dot, and then more tools, and then the developer tools. You don't have to do that. I'm just showing you like how it actually works under the hood. It's not downloading the entire data because this DM is many gigabytes. It's not downloading the entire data set. It's only based on your zoom level. It's requesting those small tiles. So if I click here, and you need to zoom in and zoom out to see that. Right. So if I come here, You may be looking at this one. You see, it's one small piece. So if you're doing your computation very, very complicated, is the time might be slower. You will see that when zoom in and zoom out, it's a little bit slower. You will see the those rectangles popping up. But this is essentially what it does. It doesn't download the original data. It's downloading the render. The data set has already been rendered. So that's pretty much it. And the overall workflow is create a map, add some data layer, display it. And what you want to do with the data is up to you. It can be very simple, just display it, or it can be complicated, like get the DM, and then you can do some thresholding. You can extract the mountains, extract the valley, whatever, and then display the result. Okay, so just pay attention to this one. Everything will be pretty much the same workflow here. So this is the DM, and like I said, for those of you who are kind of cannot remember what it is, I can just simply let me remove this one. And I can just simply change to terrain. Remove the hashtag at the beginning. So palette and then comma terrain. You see? Now I'm going to terrain. So this one is only for user that already know Python matplotlib. So basically it's a color map. I can change it to cool warm. Okay. See? Very simple. So this is not something you can easily do using JavaScript code editor. You might need to remember, or you need to use some additional packages. And if you really want to know like what kind of things you can provide, right, the visualization parameters, you can go to the Earth Engine documentation. Let me quickly show you here documentation, and then get started. So here there's an image and an image visualization. So this one, there is a table here showing you what parameter you can provide, right? We provide the minimum, the maximum, the gain, the gamma, the color palette, and also for the bands, right? So, and I mean, this is pretty much easy to use, but if you're really lazy, you have no idea what to do. For example, I mean, I can comment out, remove this one. And so if you don't really know what to do, you can just provide empty create brackets. Because for new user, you don't know, like if the ArcGIS, you open it, you can change it interactively. But right now, it will usually look like this, okay? So this is what, by default, if you don't customize it, Google is saying you're gonna figure out a way. And suddenly this is not very interesting. It's like grayscale. So what you can do, you can load any data you like, and then just go upper right corner here, go to the settings, and click this one. Okay, the data layer, you can turn it on and off, and you can just click here. It's gonna pop up the dialog box. So this is kind of like the desktop GIS, like allows you to, for example, okay, I want to change it maybe to select whatever you like, blue. You see, it's gonna show you the preview, and then just click apply. See that? Right. And earlier I used the terrain, right? So I'm gonna come here, scroll down all the way to where is it? Terrain here, right? Apply again. Of course, the range is 0 to 100. It's too much, so you can change it. You can double click here, and then you can select, for example, I say 4,000. Hit enter. Apply. See, so everything is easily customizable. You can change the opacity. You can change the range. Yes. Yeah. This is basically what Geemap is about. It allows you to do that interactively. Yeah. JavaScript is different. JavaScript is basically you use the JavaScript code editor, kind of very much similar, but it doesn't have this like select drop down list and then color map. This is only available in the Python. Yeah. And so after you, for example, after you finish this, you figure, okay, I like this color and I want to keep, yes. Open this one at one time. So let me come showing here. Okay. So like I said, I run this one, right? By default, it looks like this, upper right corner, and then the layers icon. And then, so where you turn the layer on and off, there's a settings icon here, the gear icon. Click it. It's open up this one, allows you to customize it. And you can change the range. For example, by default, it's 0 to 100, but you can change to because this is elevation. You know, the range of the elevation from 0 all the way to 8,000 something. I can type 5,000, 4,000, whatever you like, hit enter. And then the color map, you can change to any map, probably color map. So again, I'm going to select terrain. And then you're going to see the preview, right? So this is what it's going to look like. And then just hit apply. You should have it. And you can also click the import button. By default, it doesn't show you anything. So the import button is actually copying the code under the hood. So I can come back to here, and then I can Control V. You come into here, Control V. So this is a very long, but if you really want to simplify one, let me come back to here. Actually, you can specify the classes. So here by default is 255. That's why it's very long, but I can change it, for example, to 10 classes. So basically 10 hex color code, and then you can hit apply. It should look pretty much the same. And then hit import again. I can come back to here, paste it. This one should be a little bit shorter, right? So now you see the band, the color palette. Yeah, let me see if it works. Oh, and then you need to pass in these parameters to here. Remove the empty curly brackets. And then if you want it, oops. I think this is a bug. So basically, what I'm doing, if I provide the color palette, we cannot provide the band. So it should be, or maybe the gamma, I think it's this one. Yeah, we make some changes recently, so some things may not work, but if you play with the interface, you adjust it, you like it, you can keep the parameters, and then you can just plug in. But you can just use the default one that I provided. You can make some changes, make some customization. So this is basically how you stream the data from the cloud, and whatever you want it to look like, you can customize those parameters. And this is the default one using just one image, but you can also visualize the multi-spectral band. Yes? No, the number of color depends on the color palette, so the hex color code. So you can, so let me come back to here just to copy the example back over here. Right, originally it looks like this, right? So how many color depends on this one here. 1, 2, 3, 4, 5. You can add any hex color code you want. So let me copy this one just to show you the effects of this. Control V, right? So by default, you see looks like this. I can add another color, for example, at the end, right? So and then comma, double quote, single quotes. And they say, okay, at the end, I want to show a color that's maybe black, okay? So it'd be 0, 0, 0, 0, 0, 0. So that means high elevation. Anything greater than 4,000, you will be, anything greater than 6,000, you will be black color. So if you want it, you expect to see some black color somewhere in here, you see? So that means the high. So everything is customizable. It's up to you how you want to look. Yes? Yes, in your local, you use the add raster. It's different function. Add layer is just for Google sending, but you can type m.add_raster. So if you have anything on local computer, just add raster and then and you can, add vector. So you can do both local and raster. So this is the power of using the Geemap and Python. The JavaScript code editor, you can only add the cloud data. You cannot overlay the local data there, but Geemap allows you to do that. Question? Yes, there's an example in export images. So you can export vector data, raster data, any data you can export it. Yeah. Okay, so this is about visualizing raster data. So then just one image. So next, let's take a look at like image collection. So there are tons of images in there. So image collection is an entire image, a bunch of images for a specific sensor, for a specific data set. In this case, we are pointing to the Sentinel-2 surface reflectance data set. So this data set has like millions of images. And so we're just pointing to the images, and then we just simply take a median filter. Oops, it's a little bit slow here. But it's slow up like slowly. So now you see like the rectangle is requesting the tile. So if you zoom in, it's going to compute and then it's going to run again. So this example is pretty simple, right? We create a map. We're pointing to the Sentinel-2 image collection. And then we're taking the median. So what this one is doing is every location has some images, right? Intersecting with select location. And for example, here in this area, maybe we have images every a week, okay? We have Sentinel-1 and 2, right? So every year you're gonna get like 52 images. And since 2015, right, it's going to like, how many, like, 2015, 8 years now, right? 8 years multiplied by 52, like you get almost like 400 images just for one location. And globally, I don't know how many, like this is millions of images in there. So what we're doing is taking a median filter. So median filter means it's by location. For this location, you get all the pixel values, you're taking the median. The reason they take a median is like you're gonna have cloud value usually very high, or you might get some very dark area, very low. Somewhere in the middle usually is pretty good. So we're taking a median filter and we are processing the entire collection. Median images. Of course, it doesn't really do that. It's based on where you zoom in, zoom out, and the location is a reduced resolution. And then doing the same thing, we are minimum, maximum, the bands. Yes? Yes, you can, the question is like when you're doing the median filter, how you take into consideration. So you can specify what images do you want. You can specify, I only want the winter, the summer. You can filter by dates or by calendar range. Right now, we are actually taking the entire catalog, everything, but you can select subset of the images you want. I will show you the next example, is the filter it. So here right now, right, we're doing this, and then we're going to display by B4, B3, 7, and then just show you that. So what this one is doing is processing millions of images, taking the median filter, and then create something like this. Pretty nice, right? There's no cloud. If you zoom out, it's going to take some time to compute because you need to get all the images within this map view, and then it's going to do the median computation. It might be a little bit slow. You see it's starting on the ocean there. And this is like, you don't want to specify the scale first because you won't be able to do that. If you're doing the 10-meter resolution, it's going to be very, very slow. So next, let me move to the next one. This one is a little bit more complicated. So in here, right, we are using the image collection and then the filter date. So what we're looking here, instead of taking the entire collection, right now we only want the images acquired in 2021. And I also want to filter images that have cloud coverage less than 5%. And other than that, everything is the same. And now if you see the images, it's look better, right? Because we only pick up those high quality images without cloud. And we only focus in 2021. So it's so much faster and the image quality is so much better. And you might be wondering, like, how do you figure out, like, where do you get this cloud pixel percentage? So that's actually the example I showed you earlier. You can display the metadata. So usually, think about here. If you know what images you want to use, I want to use Landsat, I want to use Sentinel. Find a unique ID for that collection, and then just display the first image to see what it looks like, what attribute it has. So in this case, it will be like this, okay? So you define the image collection here, right? I can say, for example, you can just simply copy this line. Right, this is the entire image collection. And then just type first. Just see what's in there. Then now I can click here. I can see the property, right? So here you will see this one coming from here, cloud coverage percentage, right? So this one has millions of images. All the attributes should be the same. It's consistent. You can do by cloud cover. You can do by all the attribute allows you to do the selection. So this is very much similar. If you go to USGS, you're trying to download the data for your area. You need to customize, like, okay, I want the data for this within this rectangle, within this date range, cloud cover less than something, blah, blah. It's the same, but just like you are using it programmatically rather than using the interface. Question? Uh-huh. Mm-hmm. Yes, that was the name of the layer. Yeah. Yeah, you can get anything. So here, good question. So map add layer. The first one is the Earth any object. If you want to, you can hover your mouse somewhere here, and then I think you can type Shift Tab on your keyboard. If you're using Google Colab, I think it should be automatic. If you I forgot what's the shortcut. If you have a mouse here, shifted, not shifted. Yeah, I forgot. Like I don't use collab all the time. But if you're using here, if you get inside the function, shift tab, it should show you the help documentation, right? So the first one is the Earth engine object. The second one is visualization parameters. The third one is the name. And then the sort, whether to show it by default or not. And then the opacity. So here, this Sentinel-2, this one doesn't matter. You can give it any name. It's the name that's showing up here. If I scroll down, and this one is this name here, this layer name. Yeah. So I can change it to, for example, just to Sentinel. It's work as well. And sometimes you might want to add the data layer, but you want to hide it by default. You can do that as well. So you can just comma force. So that means it's the data is not showing by default. So sometimes if your computation is very slow, you might want to do that, right? So yeah, maybe let me try this one here. This is a smaller, so it's really faster, right? Force, that means, you see, it's immediate because it's not actually doing any computation. The command is sent to Google Staging. You don't do anything until you request it. If you want to visualize that, then you become a little bit slower. So right now, for example, here, if I remove it or change to true, because it caches the result. So now, if it's the first time you run it, it might be a little bit slow. But this is how it's doing. It's super powerful because you don't have to download the data anymore. You just say, okay, I want the data from Sentinel-2. I want the data for the last year. I want it cloud cover less than 5%. And I want to focus in, for example, in San Francisco or whatever, seconds. So in here, for example, earlier I showed you like 2021. You're of course welcome to change it, for example, to 2023 and then 2024. Okay. The second one is exclusive. So basically getting data from January 1st to December 31st. If you run it again, oops. Yeah, this one is, you see, it still works. And the quality might look different. It depends on this is usually this year is a little bit more cloudy. Even though it's like cloud coverage less than 5%. If you zoom out, it's global scale, right? So Google Sense is really powerful because you save your time without having to worry about the location, without having to worry about the time. You can spend more time focusing your science, like what I'm trying to address. And then if the data is global scale, we can do it anywhere. So you don't have to manage the data. In the past, you have to go to the USGS, download the data, and then you might end up spending a couple hours or download the wrong area. Or download the cloud coverage is not good. You redo it, you spend a couple hours, spend a couple days. And it's fine to do if you do it for a small area, small country. But if you're trying to download like global scale, good luck. It's going to take you days or weeks to download the data. Even if you can have the data on a local computer, how do you compute? How do you actually do the computation? You're not going to have enough memory. It's like terabyte data. But now we are doing essentially thousands of terabyte data in seconds, right? And you can filter any data you like. You can do anything. So the logic is the same. Pointing to the entire collection. Just tell Google Staging, what do you want? You want a subset? You want a specific area? You want a specific date? You want some specific attribute with the filter? It will filter that for you. And then we can directly pull the data in and can visualize rather than having to download the data locally. Okay, so that's for image collection. The next one is called feature collection. So feature collection is essentially vector data. Think about a shape file, GeoJSON or GeoPackage or GeoData frame is the same idea. And we're doing the same thing. We create a map. We're pointing to this tiger data set. And then we specify where you want to center the map at the data layer. And then that's it. And so this one is the raw data set for the entire US. So this one is like gigabyte data set. It's pretty fast. But it's not as fast as image. So Google Staging, the vector data capability is good, but it's not perfect. It's kind of still kind of slow if you have like huge data, but it's still nice. I can access to the entire data without having to download it. And it's the same thing. If you want to look at what attribute is in there, I can just come here, copy this line, and then you can create a new code block and just type first. It's able to show you that what's the feature, what's the property. So this is more like the attribute table, okay? Kind of like you open a shape file in QGIS and you open the attribute table, see what's in there. But again, Google Staging doesn't have the interface. Everything you need to ask for it. So you need to figure out how to ask for it. So this is more like some of the obstacle for beginners because you don't know, it's massive, but you need to find a way to connect to ask the right question and then to get the information out. But once you get this, you can visualize that, you can do the filtering. So in here, we're doing the same thing, right? We have access to the Tiger dataset, and this is the US state boundary, and you can do the filter. So everything, image collection, feature collection, all has the filter. So basically something dot filter. And then within the filter, you can pass in user to filter by area, filter by date, filter by whatever. Yes? Yes, so let me show you here. Yeah, good question. So I'm gonna maybe comment out this one. Similar to what I showed you earlier in the image, right? Or the image collection, you don't know what's in there, right? So the name actually is the column, got column name. So let's do this one, might be better. So, right, I create a map. I point into this image collection. I don't know what's in there. I don't know what's the column name. You can just simply just m.add layer and then just type state. That's it. So basically just add the variable and then it should look like this, right? And by default, this is what it looks. It's not fancy, but if you want to see like what's the attribute table, so this is where Geemap can help you. So load the data layer, upper right corner here, and then click this identifier, and then I can hover your mouse and click on the map. It's going to show you here, like what I click. And so the property here, this one is the name of the column. So all the attribute table, the name of the column. So you see here, like if I click, for example, Texas, you have to click this one every time, but you can click the object. You can check this one. So they by default, you're going to expand all the attributes. So you don't have to click the plus icon. So here, right, Texas. And the name here, the reason why I use the name is because it's the column name, right? But we also have population, we also have land area, we also have other attribute. This is exactly the same, like if you're using desktop GIS, you select by attribute. You like name equal to something, like name, blah, blah, whatever. Mm. Uh-huh. Okay. Yes, yeah. Do the same thing. So here, let me come back to this one here. Okay. Control C. For example, what I'm doing here, I'm accessing the entire image collection. Whatever. Right now, I'm accessing data, all the Sentinel-2 data in 2023. And just to give an example, I can limit to force 5, right? So in this case, you should get the, or I need to have this one at the end, right? So you see here, right now I'm accessing the first 5 images. So if you want to access a specific one, you can continue to use the filter, or you can convert this one to a list, and then you index the list. So what I can do here, I can do e.list. List is a little bit more complicated, right? But it can be done. I can do here e.list. We actually convert this one to a list, and then you can use the .get. So for example, I can say get. Right now, you see the 5, right? It's still the same. I can say get the second one, for example. Is it start by 1 or 0? Yeah, so here, I can get the second, you see? And then you see it's a compute object by accident image. So you need to wrap another one outside. You can see e.image. And then here, you see an e into object, and then you can use the, for example, .get info. Oops. It should. You don't have to pass. Put the .get info within the so, something is weird. Let me see. Image. This. Oh, I think the other way there. No classic here. It should be dot limit and then dot to list using this one. Dot to list. So you turn the image collection to a list, and you can do the same thing. I can, for example, 5, and then you here can use dot get. For example, the second one, you see? So now I'm accessing this image, and you see you have 23 bands, blah, 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 something. So you can certainly use the indexing, but you just need to turn that one to a list, and then otherwise you need to use the filter because the image collection itself doesn't have the indexing. Yeah, you can do it like this. Do the same thing for feature collection. It's the same. So to list, and then the size, this is the size. You need to provide it by default. Or if you want to use all of them, I can say dot collection, dot size. You're going to get all the image, all the features. Yes, it's possible. Yeah, that's what I'm saying. It's different from desktop. Like you need to train the mindset. It's like everything is feasible, but you just need to know how to get it. It's not like on a local computer, right? You have 10 images. You just click the second one, you drag into your desktop, and then you open it. Google saying like, yeah, we have millions of images. You need to know how to actually get down to that specific image. Okay, so this is how, like, for vector data, you can inspect that, right? And then you can just say, for example, I want to filter by name, or can it also filter by STUSPS, for example. So by default, it's going to display all of them. And then you can say, for example, I see the first one, and then you convert it to a dictionary. So basically, it's seeing the attribute information. Like I said, desktop.js, you can open it, you can click it. Geemap can do something very much similar. But under the hood, everything is also executing the code to get you the information, okay? And so this one example here, showing you the same thing, okay? I'm pointing to this image feature collection, and then I'm going to the filter. So this is exactly the same, like select by attribute in desktop.js. And you want to try to select, okay, if the name equal in the list of California, Oregon, Washington, I select that. And so this is going to select a subset of the feature collection, and then we add the data layer, and then you center, you see the same thing here. And if you want, you can click the button inspector. I can inspect it as well, right? So this is very much similar to the JavaScript code editor. They have similar functionality, but if you use Python, you can do the same thing in here. And so the next couple one is a bit more like customized. Is that if you want to select by attribute. So let me show you here. So I can create an empty map. Let me show you here. Map equal to gmap.map, okay? And then m, right? So assume right now this is the base map, and what else? So think about, I want to select, for example, let me add this one. So by default, I'm just adding the entire image collection. So this one is similar to like basically select by location. So I'm going to show you here, create a map, and then I'm going to paste this one without doing anything. And then just add the data layer. So this is basically the entire US. Make sense? Here, right? So right now I'm adding this. And if your area, for example, if your start area is not the entire US, you can load the data first, and then you can figure out how I'm going to get into that. So what you can do, I can say, okay, on the left side, there's a drawing tools here. You can just draw anywhere you want to intersect with your area. So I can say, okay, I'm starting the central US, right? You select a rectangle, and then you can come here. The user ROI means if you draw something, you're going to use it. If you don't draw something, you're going to use the default one. So right now, if I run this one again, see? If you zoom out, you see that it's selected because we have two data layers. If I turn this one off, you see, in the setting. So you can select by attribute, you can select by location if you want to. It's feasible. And the next section here, I'm going to go very, very quickly because this one shows you how to customize the data in different color. So feature collection has the function called style. Style means how you want to style it. But usually, I mean, for new users, if you don't know how to get started, the easiest way is just to point to the data, add the data layer, and then use the tool to customize it. So I'm going to show you here, right? Can you understand this code block? Right? Simple, load the data. And then you can start from here. I'm going to come to here, click the layers button, layers icon, and then the same thing, right? You can turn the layer on and off. There's a settings icon here. I can open it. And this is where you can customize what you want to look like, right? You can say, okay, I want the color to outline to be, the opacity to be maybe the light color to be red. Apply. Is it? Right? And then I can also say, for example, I want the fill color to be red. Okay. Opacity, you can change it a little bit. Apply. Make sense? So this is easier. So if you don't want to like doing the coding, but you can click the import button, you can grab it, and you can pass it back to the code after you are satisfied with that. If you don't want the filling the color at all, you can change the opacity to 0. And then if you run it again, it should be just the outline. Yes? Yes, so here, right? Again, the import button. If you click the import button, you copy it, and then I can come back to here. I can paste it. It looks like this. The style, something, right? So, and what you can do is to, in here, map.add layer, the state, dot style, and then parentheses, and then you need to put double star style. So basically, it's a dictionary. You unwrap the dictionary is something equal to something. So right now, if I run this one, you see, it's your code is preserved. So whatever you do earlier, so the style basically means something like in here, right? So the color is the outline color, the width is the line width, the line type, and also the fill color. So the fill color here, you will see by default is 8 digits, okay? RGB and then opacity, okay? So if it's 00 means it's fully opaque. And if right now, if I ask you, how do I change the fill color to blue and then half transparent? Anyone? I want to change the fill color to blue and then half transparent. So what's the hex code for blue color? Yeah, and so you'll be 0000 FF half transparent, right? So FF is like fully, so you can drive FF and let's see what again, right? You see, fully blue color, right? So if you want to transparent, it's the last 2 digits. So you can think about roughly 80 something. So you put 80. It should be slightly transparent. So basically everything is customizable, but you just need to figure out how to do it. You can use the interface to get you to that and then just copy the code and then you just make some changes. This is usually a little bit challenging for beginners. But now it's so much easier. When I got started like 4 years ago, this is not even possible. It's like, it's not easy. Transparency. So, but you don't need to, if you don't want, you can just keep the last, the 6 digit, it should work as well. But it's just fully, it's just FF if you don't provide. If you want to be transparent, like I can do F00, then it doesn't matter what color you provide, it's not going to do anything. I can do the same thing here, right? FF, I can change it to 80. You will also be transparent, right? I can change the line to be, if you really want to be thicker, I can do it a bit thicker, but you can, so everything is in the cloud. So we are actually, the data, the Google Sensing data is in the cloud. We are just requesting it and then how we want to visualize it. But we don't actually change the original data. All the data are immutable. It's just, you are requesting a copy of data and then how you want to visualize that. And you can even go a little bit further if you want to, right? I can do the style. You can do something like this. This one is a bit more complicated. You can have the color. You can use a column. You can say, okay, I want to use that column to visualize the data. So you can, for example, I can change it. Let me go back to the original data set here without the style, just to show you how you can customize by column, right? So again, this is a state boundary and it has a lot of columns. So I can go here, select this and click it. And you can take a look at what column it has. For example, A lane, the lane area, water area. I'm not sure it has population or no population. So you can see, for example, I want to create a map showing the US, and I want to show the color by lane area, for example. I want to see which area, like large area, lane area, smaller. You can use the color to do it. So what you need to do, for example, A lane, right? I know the name of the column. I can come back to here. I can just simply, in this one here, I can say A lane. And what is this doing is going to use those color, but it's going to customize. This one has how many colors? 1, 2, 3, 4, 5, right? 5 colors. And the lane area means those like have larger lane area. You would go to see it's all the white color because it's larger area. And this smaller one here is like smaller lane area. So you can actually, it's exactly the same like desktop GIS. You create a core cluster map based on a column. It's doable. Same thing here. And if you really want, I can also like change to other color if you want to. But this is a bit more like advanced in terms of visualization, but it's doable. Okay, so that's about some simple visualization. And I only show you a couple data sets, but next one, let's get into like, where do I really find the data? So you can go to the website, Earth Engine Data Catalog, you can do the search, you can go to the community data catalog, but Geemap actually have everything built in. So you don't have to div the interface, you can do everything inside. So I'm gonna show you here, just create an empty map. And then upper left corner here, if you click this icon, and then there's a data tab. So I recommend you just click on that and then click the data. There's like, it's not perfectly aligned because Jupyter Lab and Jupyter Notebook, like it's perfectly aligned on Jupyter Notebook, but not on Jupyter Lab. There's a weird issue that reported by Snowfish. So this is where you can actually source the data. So kind of like this is, you're going to Netflix, you search a movie, you want to watch it, it's the same thing here. So I can do example, I can search lane set, or I can say elevation. I want to look at some elevation data. Oops, do I have any typo? Okay, elevation, hit enter, and you see, like all the elevation data. So some data from the Earth Engine Data Catalog, some actually from the community data catalog. So it's already built in, so you can select whatever data you like. I can say, for example, I want the, for example, SRTM, right? The one we used earlier. You click it, and it's going to show you the metadata information about that data set, right? So you can see the date, the image collection ID, the date, and the preview. So here, what you can do is to simply click the import button, okay? So if you click the import button, it should show you this code block. So this has been converted from JavaScript to Python, so you don't have to do that manually. So once you click the import button, I can go back to the map here, and then I can just add a new line, Control V. It should be automatically copied to a clipboard, and then I can run again. See? So it's so much easier that you don't have to actually go online to source data. Everything is embedded already in there. You can continue to source any other data set you like. So for example, if you any lane cover or maybe fire or anything. And you can, for example, I can click USGS, US gap analysis, right? 2021, same thing here. Click the import button, and then I can come back to here, place it, Control V, hit enter. See, you can change the color, you can customize. So, but the idea is that you can search any data set in the data catalog. So right now it's over like 90 petabyte. You can grab any data you like, and then you can just simply visualize that. Then you can customize the code, for example, the whatever is showing up in here, DM, lane set, whatever. And yeah, so the next code block is pretty much similar. You can customize how you want to look. So the important thing is to get the unique ID, the unique ID of that data set, and then you can customize the visualization. You can do some analysis if you want to. So right now, we haven't done really any analysis yet. What I'm showing you here is that how to get the data, stream the data. But there are a lot of things you can do with the data set. And I'm going to skip this portion. But the next one quickly, if you have some JavaScript, so for those of you who are JavaScript users, you already have some JavaScript you want to convert to Python, Gmail also have some tools that can help you do that easily. So what you need to do, simply create an empty map and then come here, upper right corner, second row, second icon, if you open it up. So this one allows you to convert JavaScript to Python. So I can go over to, for example, to here, to the Earth Engine documentation, somewhere here. Right now, they already have all the Python examples. In the past, it's only JavaScript. So what I can do here, just come here, copy, and then hand over to here, Control V, and then just say convert. It will help you convert the JavaScript to Python. And then just, it's already copied to the clipboard. Then I can come here, Control V, run it. See, you're gonna get the same result as like what you are getting from the JavaScript. So if you really want to do some conversion, but you don't want to spend too much time, you can use the automatic conversion. But keep in mind, this is not 100% bulletproof, because if you have some like chart, or you have some functions that not supported in the Python, you want to run into error. But for most of the Python code that you see in here, it should work out of the box. So I can copy another one here, copy, come back to here, and then I can run again, paste, okay, convert, and then I can come back to here, Control V, paste. Oh, it's hidden. So by default, the data layer is hidden, but I can turn it on. But you need to zoom in to the location you see here. Okay. So this is more like a shortcut for users that want to use Python, but have a lot of JavaScript examples. Okay, so that's the basic about searching the data, visualize the data. So what I'm doing is showing you how to search Netflix movie database and how to watch the movie. That's it. Right? It's simple. Now you have the entire 90 petabyte of like database for free. You can stream any data without having to download anything, and it's just using the browser. Exercise 1. I will provide the answer keys later, but we don't have time for you to work on that. But you can essentially filter any data you like for any time period, for any location, based on certain attribute. So basically what you're doing is select things by attribute, select by location, and they can combine images to do whatever you want. You can also create a time series. I will show you some examples later. Questions? Uh-huh. Uh-huh. Mm-hmm. Yes, if you want to, you can export the. So the question is whether we don't, after doing analysis, can you like export the data as NumPy array or something like that? Yeah, you can, but you have to keep in mind you should avoid doing things like mixed local and server. You should try to finish all the analysis in the cloud and then get a small piece of data set or some statistics. But the DM, for example, is many gigabytes. You're not going to be able to convert, like getting it all at once. So the analogy would be like this. You are watching a movie on Netflix and you're asking, okay, give the movie to me to my local computer. It's not going to work instantly. You can get a small piece, you can get a thumbnail, you can get like a style sample size. But if the movie is like 10 gigabyte, it's not going to give you 10 gigabyte like instantly within a second. Yes. Yes, they have total analysis too. And the next one, like we didn't cover here, is the one called XEE. That allows you to convert Earth Engine data object to X-array. And they also right now you can convert vector data to GeoPandas. So this is a new package that was created. If you want to get data out, try this one out. It's can help you do that, but it's a bit tricky because many of the data set in Google Engine like virtual mosaic. For example, what we did earlier, create a virtual mosaic of the entire globe. It's many terabytes. It's not going to be able to like get it very quickly. So the recommendation would be do all the computation within the cloud and then just get a small piece, summary or something like that. You'll be much faster. Yeah, you can. Yeah, you can do that. Yeah, certainly it's feasible. Yeah, get compute, get pixel, but like I said, it's usually for small region. If it is too much, it's going to be too much. Yeah. Uh-huh. Mm-hmm. Mm-hmm. So the limit, I think drafting will be normal. But in terms of like getting data out, if you're trying to get directly to a local computer, the default one in the past was like 32 megabyte. But now because the XEE is a little bit more, it's more like lazy computation. But if you export to your Google Drive to cloud storage, it's I think like 24 hours. Right? If the computation runs more than 24 hours, you're going to time out. 5 days? Okay. Yeah. Mm-hmm. Mm-hmm. Mm-hmm.
And also because there's no concept of like how large, so everything running in class, right? It's usually something like the work of you don't have a guarantee how big the machine is, how much storage. There's no guarantee that when you go complete it, they can't say everything after the 5 weeks, right? I believe right now the wall, my max wall is 5 weeks.
Mm-hmm. Yeah, yeah, yeah. Mm-hmm.
But it's not a guarantee either. So if the pool is lower, so
Mm.
then we won't make that limit. But maximum number of class we can compute is 3,000.
Mm.
So essentially you can have 2,000 objects that you keep class. And then your export will run either like those 10 objects as each completes. So the next task that was queued will change into running status. And then we'll have that running and go on. So you can, that's the maximum concurrent task that you can run at any given time. XE uses something on a get compute that pixels. So basically what it does is it uses a high volume point, it tries to go back to blocks of things. And it kind of does like local vectors, but in a gridded approach. And I think Geemap also.
Yeah. Mm-hmm. I will show you some example how to get the data out later. So we only have half an hour, but we're gonna cover maybe 10%. But again, the notebook is here. We can go through quickly, just show you the result, and you can digest it later. So next, I'm gonna show you the inspector tool. So the inspector tool basically allows you to inspect features or pixels, values, something like that. This is very much similar to desktop.js, right? You open an image, you click, and then you can get a pixel value. You can select polygon. Same thing here in Geemap. So I load a bunch of data layer, and then you will see here. Let me open it. So by default, after load the data layer, upper right corner, if you click this one, this is the inspector. So you can inspect raster data. You can inspect pixel vector data. So if I click here on the map, it's going to see here, I have 2 data layers, right? I have 3 data layers, the polygon, the length set, and also the DM, right? So those are the 2 raster data layer and also the vector data layer. So shows you, for example, the elevation for the DM and also the pixel value for the 6 spectral bands. You're welcome to click other location. So if you click somewhere that has vector data, it's going to show you here the object at the bottom, right? So this gives you an easy way to get this the data. Yeah. Yeah, yes, yeah. Yeah. Mm-hmm. So you see here, right? 521. If I zoom out a little bit, it might change slightly, or still 521. So the reason for this is the data is not on a computer. The data is in the cloud. So what we're doing here, you click your mouse on the map, it get your coordinates, and then it send the coordinates, we will send it to the computation and get the result, pass it back. So it's not like instant, like compared to desktop, because all you have data access to all the data. What we're doing here, we don't actually have the data. It's just sitting in the cloud. Everything you need to ask for it. You need to ask it for do computation. So this is called the inspector, but you can also use the plotting tool. So for those who are doing remote sensing, this might be something you're familiar, right? Again, I'm going to show you how to get started, right? Load the data layer, and then upper right corner here, first row, second column. If you click it, and it will show you like you can select, these are basically the data, the name, the layer name, and then you can select, for example, here is lane set, right? You just click your mouse on the map. Oops, I think there's a bug, so it's let me see here. We recently make some changes. Some of those made the new bugs. Okay, so you see, right? I click here. This is more like the spectral signature. So if you have multi-spectral data, you want to inspect the pixel values, but you also want to see the plot, and then you can do it here like this. Right? You can click on the water. You know the water spectral signature is going down, and you can also change to hyperspectral, right? So I'm going to select the second one, Hyperion, but you need to zoom in a little bit to see this Hyperion data, and then click your mouse on the map. It should show you like hyperspectral, the spectral signature. This is the default one. If you don't like it, you can customize it. So for example, I can change the selected the options, right? I can run this one, and then I come back to here, I run it again. You see, now it's changed to the bar plot rather than the point with the line. And you can zoom in, you can zoom out. You're also going to add a point, add a marker cluster. So we zoom out, you see it cluster into a point, right? So we click here, something like that. Yes? Uh-huh. Oh, it's overlay. So because I didn't run this one, but the overlay means that you can show on the same plot. So it's probably too much for the hyperspectral, but for this one, if you run this one here, set options, add marker cluster, and overlay means you want to overlay multiple lines together. So now if I click my mouse on the map, right? Oops. It's supposed to clear up, but now you have multiple lines on the same plot. It's to clear up the data layer, I think. Uh-huh. Oh, I see. I know what I'm saying. There's a bug on Google Colab. I think they treat things differently. So that's kind of tricky thing. Like some of the iPad widgets work locally, but you won't work on Google Colab. So I would recommend just rerun the code block and then just run it again. Yeah, that's something we need to improve in the future. So that's about the what's they called? The plotting tool. And next about some of the legends. Earlier there was a question about like how to create a legend. You can do it in here. So I'm going to simply I can skip some of the code block, right? So this one here, we're adding NLCD. On the right here shows you the legend, right? So Geemap has some built-in legend. I just typed up, for example, NLCD, you will get an NLCD legend. But if you do some lane cover classification, and then you want to customize the legend, you can do it in here. So let me show you. I think let me skip to this one. Okay. So what we're doing here, I add the base map, Esri base map, and this is basically the legend, how you want to customize it. Then I add the NLCD 2021, the data layer. I just display the lane cover map. And if you want to add a legend, it's this one. Map.add legend. And then the title is the title showing up here. This top here, NLCD lane cover classification. And the legend dictionary. So the dictionary means you have a key, the text, and also the color. Okay, so you see here the dictionary 11 open water, and then like the hex color code of the color. So exactly like in here, you're showing up here. So everything is, if you want to add something to that, you can easily customize it. For example, you don't want like open water, you don't like it. I want to change it to just water, that's fine. And you can run it again. You see, now it becomes water. So this is about the legend, and then there's color bar, color map basically, right? So in here, I add a DM. I also want to add a color map to the map so they can see the color ranges, right? From 0 to 4,000. So the function that you need to call is called map.add color bar. And then just passing whatever visualization you used to visualize the data layer. And that's it. So you don't need to make much changes. So for example, here, I don't like this color. I show you here, right? I want to change it to something else, just like what I showed you earlier. Right? I want to change it to terrain, right? I only change this, everything else remain the same. So now if I go to the map, you see, it changed to this one. I can change it to warm. Do you see it's being updated automatically? So the color map So for JavaScript users, how do you do this in JavaScript? How many lines of code need to write? It's many, many lines. This is like so much easier. One line of code, just passing whatever you want, how you visualize, and then you can do it easily. And the one is linked with the data layer. So if I come here, if I turn the data layer off, it should also be gone. Okay, so the legend is the color bar is also hide. Okay, so it's linked to the data layer. And for example here, it's horizontal, but you can change it to vertical. So you just change the orientation to vertical, run it, you see, vertical, 1 second, like very responsive. If you don't like the background color, you can make transparent. You see, now it's transparent. All right, so this is based on iPad widget. Everything is like very customizable. You can change the color, you can change the background, you can change all kind of things. So loads of things can help you easily visualize the data. Next one, split map. Okay, this one is like very popular. If you have multiple data layer, you want to compare them side by side, you can just use the map.split map. And then, so this one right now, we're only using like the base map. We're not using Google Sensing yet. But I'm showing you here, you can use the slider and then you can slide the layer on and off. One line of code. JavaScript users, how many lines you need to write to create a split map? It's many, many lines of code. So let me show you another example. This one is using Google Sensing. So what we are doing here, we are pointing to this Earth engine image in 2001, and we have another one, 2021. And then instead of map.add layer, we are using the Geemap.ee tile layer. Okay, but the parameters are the same as the m.add layer, but we're just requesting the data layer, and then you passing to the split map function. And look at this one, right? So right now we are pulling the Earth engine data layer, 2001 and 2021, and you can use this slider to see the changes, right? So let me zoom into the famous Las Vegas here, so that you can see the differences. All right, so on the left is 2001, on the right is 2021. Can you see the changes? All right, one line of pretty much is one line of code. This can be tens, hundred lines of code to just use if you use JavaScript, because they don't have that functions built in. You're welcome to replace this left layer with any other Earth engine data set, any data set. And then you can pass in how I'm going to visualize. For example, you can have lane cover, lane set data on the left. You can have lane cover classification on the right. Whatever way you want to customize, you can do that easily. You can also do the link maps. This one doesn't work on Google Colab, so just keep that in mind. So link map basically means if I move a map, it's linked all together. So you can, what this one is doing is like we have different bank combination. You want to see all of them all at once, so that you can figure out which bank combination might be better to highlight a certain feature. I can zoom in, it should all link together, right? Zoom out, I have a mouse, right? Again, this won't be available in the JavaScript. You have to write many lines of code to do that. But this is only one line of code, and then how you want to customize that. It looks quite complicated, but if you read it, you should be able to understand it and then customize to different data layers. So for example, you can have lane set, you can have Sentinel, you can have lane cover classification, you can have temperature, you can have all. It doesn't have to do 2 by 2. You can have as many rows, as many columns as you like. Yes? Oh, this one, yeah, good question. It's feasible, but it's not in this function. You need to write a couple more lines of code to add, for example, add a legend to a certain subset. Yeah, it's doable. Yeah, you can customize it. So in here, you can, when you create a map, you can pass in where's the location you want to get started, what's the zoom level. You can just pass in the parameters in here. Oh, this is not, so right now, in terms of layout, the scale bar, the nose arrow, yeah, those things is doable, but it's not very convenient right now. So Google Sensing and Gmail is more like for computation, but it's not really a cartography software that can create. It's not that complicated because it's all on the web. We don't really have a lot of like those components to make it work. But yeah, so that's about the sling map. But the next one is called time slider. So time slider is like when you have a lot of data layers and you don't want to add all the data layers to the map. So the time slider might be useful. Again, this one probably doesn't work on Google Colab, so it might crash. Just want to let you know. Oh, the time inspector means that you have a collection and you can have a drop-down list on the left, another drop-down list on the right, and then you can change the data layer, right? So in here, it's basically the same split map, but I can change it, right? So the NFCD has so many time periods. Let's say, okay, I want to compare 2011 and 2019, and I zoom to the same area here. Right now there's the diff map have something. It doesn't easily. Suppose you can drag, and then right now it doesn't work yet. But what I'm showing here, right, I can change the data layer on the left side. It should be updated automatically. Okay, 2001, 2004, and then 2013, right? And you can zoom in, you can zoom out. Yes. Say that again. What do you mean 3? Uh-huh. Mm-hmm. Yeah, you just need to basically, in terms of the computation, you can design whatever algorithm you want. Later, we have some example that can show you how, for example, do lane cover analysis, forest trains analysis. You can do the computation, get the result, and you can see or you can get some numbers. So it depends on what you want. Questions? What do you mean? Do you mean this year? Uh-huh. Yes, so everything is in the cloud, so you can export the data, or you can use the inspector to see the value if you want to. So in here, for example, right now, yes, you can download it as well. So it's up to you. This one here, yeah, you can use the inspector too. So for example, this one right now I don't. So how about this one? I can show you here. Oops. Yeah, you can use the inspector tool to inspect any raster data layer, any vector data layer. So here right now, for example, I'm using the modis data, right? The collection and then blah blah. I can add the first image. For example, I can add layer, right? And then I have this collection. I'm just going to see the first one. So first, okay, oops. And then comma, and then I can say VIS, ERAS, and then say first image. And let me comment out the second one here, just to show you what it looks like, okay? So for example, right, I'm loading the NDVI data, right? Yeah, you can, if you want to inspect it, click here, and then come here, you can click the NDVI, right? You can get a pixel where it's in here.
I think the question is, let us say you're doing the stamp comparison, right?
Huh?
But this up and on your
Mm-hmm.
what if you wanted to download the stats for that region?
Oh,
What was the change?
yeah, I show you examples later. Like there's some zonal statistics you can quickly run to get the result. But I'm just showing you like here we have, for example, this NFCD, no, the modis data, right? We have daily images, but right now we have 30 images. I want to visualize them. So what this code block about is using the time slider. Again, this one doesn't work on Google Colab. So it's adding this time slider at the bottom here, and then you can just click on that. It's going to loop through the data layer. So rather than adding 30 images to the map, we are actually only adding one layer. I can pause it. I can say, okay, I want the images for June 22nd, right? I can pass it through. So basically, these are tools that are useful if you want to visualize time series, but it doesn't necessarily do the computation. It's just loading the data. Just like you're watching TV episodes on Netflix. You select, okay, I want the episode season 2, episode 2, something like that. So just some tools that allows you to do that rather than you have to convert to the list and then get index and then select it rather than. Yes. Right now we're only doing visualization. So let me next go to, I'm going to skip some of this so that you can do some analysis. Okay. So the next I'm going to skip to some analysis part because we only have 10 more minutes. But here, if you go to the zonal statistics, I can quickly show you how to do statistics. So look at this example, right? I have the DM. I also have the US state polygon boundaries. So right now, if I ask you a simple question, which US state has the highest average elevation? Is it a reasonable question? Like basically, which US state like the elevation is on average very high? Based on what you're looking in here, right? Can you guess? Colorado, right? It's like white color. It's very obvious. How about which state has the lowest average mean elevation? Which one? California? No, California definitely not. You see all the, look at the green color, right? It's hard to guess, but this is where you can do really zonal statistics. And it's actually just one line of code. So in here, or the scale bar. Yeah, you can change the color ranges to make it more obvious. Yeah, you can change the range. So basically in here, we have this, the DM here, right? 0 to 4,000, you can change it. You can also add the color map, just like what we showed you earlier. You can add the color map to the map if you want to. Yeah, but you can guess, you can use the inspector. You can click on the map to give a rough estimation about the ranges. So here, right, very simple. There's only one line of code. So in Geemap code, zonal statistics. If you use ArcGIS, you might be familiar with this one. So basically, give an image, give you a zone. So basically the group, and then you can figure out, calculate the statistics within each polygon. So what we're trying to do here, we have the DM. We want to calculate the mean elevation within each polygon. So using the zonal statistic and the type is calling the mean. And this is where you set the scale. So earlier there are a lot of questions about the scale. This is where you set it. The smaller the value, the slower. So this DM is 30-meter resolution. If you want to compute by 30 meter, it might take some time, but we are only using like 1 kilometer. So if you want it, you see, 1 second, it's done. So now if you want to, it's on the CSV, refresh. If on Google Colab, it's also should be saved to your directory. So now if I can open it, you see, now I have this CSV. So this is basically the polygon attribute table plus this mean column that we just calculated. So, but right now, the state polygon has this column showing you the mean elevation. It might be difficult, but I can just run the code here to convert this one and then turn into a table in here and showing you, for example, the mean elevation. We are sorting from in the ascending order. So you see the mean 13 point something, and you go to the end, it's right 2095, right? Which one? Colorado. So if I go back here, showing one more time, which one is the lowest? Delaware. Okay. And this one MP, I think is the Mobile Island or something. Okay, Virginia Island, Florida. Right. So you can actually do some statistics if you want to. So this is just simple zonal statistics. Give you a raster, give you a polygon, you will do the statistics. But you can also like do multi-spectral bands, right? I can also do that on a Landsat data. The same thing. So Landsat has multi-spectral bands, right? So it can B1, B2, B3, B4, whatever. It can also calculate the mean DM values, but this can be used to apply, for example, they say I give you a temperature data for the US every day, right? Everyday temperature. I give you like 365. And I want to calculate, for example, the average temperature for every state during the past like year. You cannot do the same thing. You just give an image. It doesn't matter how many bands you have. Just give me a polygon, and then you run the analysis, give you the result. And you see this is pretty quick. It's seconds. Compared to in the past, you have to download the data, and then you run it. If the data is huge, it's going to take you hours. This is seconds. So this is called zonal statistics. But there's another one here, zonal statistics by group. Okay, by group means, in this case, I have the lane cover data. I also have the polygon. And I ask you the question about, for example, which US state has the largest agricultural area? Which US state has the largest forest cover area? Can you guess? Yeah, you can look at the map, you can try to guess, but you can just use one line of code to get the answer. Or I can ask the opposite. Which US state has the largest forest coverage compared to its state area? So if you're trying to figure out, you're working the USDA, you're trying to figure out, okay, which state produce most like crops or forests or whatever. It can be absolute number, or it can be relative to its area or to its population or per capita, whatever. Those things can be easily done in here. So the function is called zonal statistics by group. Give me the lane cover and give me the state and where you want to save the result. You can be saved as a CSV, or you can save the feature collection. And then the first one here, statistical type, the sum means we're calculating the total area. And the denominator basically means, okay, by default is square meter. We're going to convert it to square kilometer and then keep 2 decimal places. Again, if you want to see the complete documentation, you can see there the parameter you can customize where you only use the default one, and then just run it. It should take a couple seconds. You should be able to get the result. Again, this is just one example. Think about it, not just for land cover. It can be wetlands, different type of wetlands, or different type of forest, or different type of urban, or something like that. And right now, if you don't specify, it's using the 30-meter resolution. So this is certainly taking a little bit longer, but I can specify scale equal to 1,000. It will reduce it, and then it will be faster. Yes? It's here. So it's under your, if you're in Google Colab, it's on the left side here. It's under here. That's what I'm saying. It's temporary. If you close it, it'll be gone. But if I'm local computer, it's saved to my computer under my C drive. Yes. So in Google Colab, you should be able to go in, and then you can, for example, here, click download it. You can download the file to a computer if you want to. Yeah. And then you can convert to CSV, for example, so you can easily get the data out. So this is the recommended way. Do all the computation is just download some summary data rather than download the original data, right? So the lane cover data is many gigabytes, and also the vector data, but the table is very small, so it's very fast. You can answer the question right now, like which one has the largest agricultural area, forest area, or which state has the largest amount of urban area, for example, right? So those are common statistics you might want to get. You can also get the percentage. If you want to like the length, for example, like each state, you have the land cover, but you can calculate what's the percentage of land crop, what's the percentage of forest compared to the total area of the state, right? So those are things you can also do. You can also do zonal statistics by 2 images. We only have 1 minute, but here it basically shows you, for example, I have the DM, I also have the NLCD, for example, right? I can calculate the zonal statistics by the 2 images. For example, you can say which land cover type has the highest mean elevation, or which land cover type has the lowest mean elevation, right? So this one is not polygon anymore. So it's the land cover, right? Different category, and also the DM. So in this way, you can also use the zonal statistics by group or by zone to do that. And then you can export the result. You can convert it to a CSV or download the data table. You can just run through it. We're out of time, so we don't have time to show you, but we are only finished 3 sections, but I want to quickly go to the last one. I think that one might be more interesting. So you can actually do analysis. There's example about forest cover. and also how to export the data, export what images, image collection, visual collection. So basically you can get any data out of Google Search Engine if you want to. And the last one I want to show you is like, this might be something that might be useful for you because you can create animations very easy. So for example, I can show you here, create a map. And you can simply draw a rectangle on the map if you want to. And maybe here, showing how to create animations, right? So there are tons of data on Google Search Engine. Sometimes you might just want to quickly show you some animation to show the changes of the images rather than having to download the original images. And you see, so now I can create animation for certain location. It doesn't what data. It can be any data set as long as you have a time series. So what I'm showing here, this is using the 1 meter resolution, the USDA net imaging, 1 meter resolution for all the area, for the area. But I can also do lens set, okay? So in here, so what we're doing here, we create lens set animation from 1984 up to right now for certain area. And usually it takes only 20-30 seconds. You will be able to see the animation. So this is quite powerful if you want to use longer time scale data to quickly see the changes before you use the data for analysis. This might be useful. So you see, so now we have lens data annually for this specific area, so you can see the changes of the river dynamics. And this, before Google Search Engine, this can take you hours, even days to do that. Think about, like, as I mentioned earlier, right? Let's say you have every 2 weeks, you have 1 images. And every year you have 20, 30 images. And since 1984, how many years? 4 decades. So you're dealing with tons of images. You need to download it. You need to remove the cloud. You need to do the mosaicing. You need to, if they happen to be like between the 2 lens thing, then you need to, it's like a headache. This, 1 line of code, 20, 30 seconds. Compared to 20, 30 hours, like so much faster. You can be Lancet, you can be Sentinel. So there are tons of more examples in here if you want to try it out. Sentinel, oops. Lancet, a different area, Sentinel 2, Modis. I think the one I want to show you is still downloading. So this one is the famous Las Vegas, right? So you see here, you see the change. So what this one is doing is that you can select any area you like. You can select any time span. You can create data by year, by quarter, by month, by date. It's up to you. So everything is customized here. Of course, your data need to be able to support. If you have daily, Lancet doesn't have daily, so it's not going to work. But if you like use NDVI, Modis data, they might have daily. So this one here, maybe show you this one, the Modis data, right? You can see everything pretty much is like 1 line of code, 1 code block. Then you can create animation. So if you have a time series data, you want to quickly show the changes rather than downloading original data, or you have to show other people the changes. This is the most effective way of getting the data and then create a GIF animation or MP4, and then you can share with other people that without GIS or remote sensing background. I don't know why it's, because I run this code. It's still running? Anyway. Try it out. Just once, look block by block. Again, there are tons of examples in here. We don't have time to go through all of them. And lastly, let me take one. I recommend, so if you, here it's up, right? How cool is this, right? NDVI and 1 line of code. You can create animation, so you can composite a lot of data, and then it could quickly show you the changes. You can even, not just for NDVI, so the last one, maybe this one, the volcanic eruptions, for example. Right, if you already know the specific area, the time, and the bounding boxes, then you can create those animations easily. So it is like short time span, but it's every 5 minutes you get one images. And you can see, right? You can capture any weather and climate events using the data because Google essentially ingests the data every couple minutes. So you can get the most real up-to-date data about weather, climate, or wildfire or anything. You can do it easily in here. Yeah, try it out, see if you like it. And the last one here, if you're really lazy, you don't want to write code, Gmail also has that. So I can just create a map and then I can come here, click this icon, and I can zoom to anywhere you like. Of course, this one is not very useful, but I can just simply draw a rectangle somewhere here and then just click create time lapse. Just 20, 30 seconds, you have that, all right? So now there's no excuse. You can just open, create a map, zoom to anywhere, change the year, whatever, and then create the animation. And then you can overlay on top of the map, you can zoom in, you can zoom out. You can also download that one as a GIF, and then you can share that on social media. So now if somebody share it online, now you know how to create it. 20, 30 seconds. It's not a mystery anymore. Anyone can do that easily. You just need a little bit patient. It might take sometimes a little bit longer, depends on the number of images in process. You see, it's done, right? And then I can remove this rectangle. Of course, this area doesn't have really much changes, but you get the idea. I can zoom in, I can zoom out. It's overlay on top of the base map, right? And here you can download it and save it to your computer. And now you can open it, see, on your local computer. Okay, so that's all I want to show you. I'm sorry we are running like late, but lastly, I want to point out, if you miss other section we don't have time to go through, you can go to Geemap and then you can go to my YouTube channel. And so here actually we have the playlist. Actually, this is the one, Google Search Engine Geemap workshops. So this is like 4 hours that I presented like last month in the Geo for Good Summit. We have more time to cover all the sections. So again, watch the video if needed, but if you have questions, you can email me. Happy to answer your questions. Thank you. Yes, yeah, you can answer question. Yeah. Question? Yeah. Uh-huh. Yes, yes, certainly. So we only show you the simple one, but in terms of like the example that they are saying, like for example, temperature over the past 30 years, you want to analyze the trend of the temperature changes, for example, in the US or by state or whatever, you can use the same thing, the zonal statistics. So what you need to do is to have create an image, and each band represent the temperature by year, by month, or by whatever you like. And then they say you have 10 years, right? 12 images by monthly, you have 3,060 bands, and then you pass in the country polygons or the state polygon, you do the zonal statistics, you will get the table, and then you can use the table to create plot. So this is something that we didn't have time to cover, but if you go to, let me quickly show you here. Actually, the forest cover changes. They want to show you how to, for example, do statistics and then create pie charts, bar plot, something like that. So it's actually under here. Again, we didn't have time, so we skip this one. For example, in here, right, you can analyze forest cover changes during the past 2 decades, for example. And it's using a similar stuff using the zonal statistics, but there are a lot more. This is only 0.1% of what you can do. The algorithm, it depends on how you want to design it. Gmail only helps you create a map and then visualization and then some simple way. But how you want to build a house, how you want to design the house, it's totally up to you. We only provide the building blocks and some materials and some template, but there are a lot more things you can do. Mm-hmm. Yes, you can do that. So, Yeah, so I can quickly show you the result here, for example. So basically, when you do the computation, you by default we use the EPSG 3857, so the web marketer. So it's by meter, but you can define what projection you want it to compute. Zonal statistics, they're using the web marketer projection doing the computation. It's not using the 4326. Yes. Yes, you can specify the coordinate system you want it to compute. Yeah. Mm. 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 So similar to the example here, right? If it runs through the So this is example that we didn't have time to cover, but this one analyzed the forest cover change, right? So you can have data forest cover change during the past since 1984. And then you have countries, so you can figure out, for example, which country lost the most forest cover, or in terms of all the forest lost, which country lost the most, for example, right? So you can quickly create some of this kind of a pie chart or bar chart, and you can easily figure out, for example, forest gain, forest loss, land cover change, or anything. This is just a simple example we can do by country, by state, by county. Again, it's more like the framework, not specific about what data you use or what scale you use. It's just zonal statistics. If you give an image, if you give me a polygon, it will do that for you. And the image can be continuous, it can be categorical, it can be whatever you like. So it can be temperature, it can be elevation, land cover, you name it. But it's more like, how do I do this one using your custom data set? So just follow the examples and then just change some of the data set to your own data set. And then you'll be able to get the result and do the computation. But most of the things we focus on like visualization, but there are a lot more things you can do with Google Sending. Sorry, we are late for 10 minutes, but if you have any questions, I'll be able to talk to you. But welcome to check out the Geemap website. There are a lot more examples in there. And then also the videos. You can also ask questions on GitHub, or you can email me. I'm happy to see what you can do with Google Sending and Geemap. Thank you. Yes. No, this is just your account. It's not a problem. It's the same thing. That's more like the Google Engine. I think you are early user, like sign up very long time ago. That one is like problem. But if you have other account, it doesn't show that anymore. So what you can do is to authenticate and then set a token on the collect. You don't have to do that anymore. It's fine. No, it's fine. It's no worry. Yeah, yeah. It's fine. Yeah. Yes. Yeah, the book. So actually, so here, if you go to the Geemap website, at the homepage here, actually I published the book. If you were interested, you can on the left side here, there's a book icon. So you can go through all the examples. All the source code available. So you can just download it, you can run it on Google Colab. So in here, I can just click this one and then open in Google Colab. So everything is reproducible. But if you want the hard copy or you want the PDF, then you can purchase it from the local press. But usually I would just ask people, just spend some time, go through the examples, and then you can do that. What we cover today probably only cover 5%, 10% of what the book is about. Yeah. Okay, so that's all for the workshop. Hope you find some new stuff that you didn't know, and hopefully convince you to use Python.